Hi grade 12s, welcome to my channel. Let us now revise some more for our Term 1 exams. We're going to take our paper from the Northern Cape, and this was last year's Term 1 exam. What is important about these papers I've shown you guys is because the content is the same as the content you're going to be examined on. And what I liked more is that these two papers seemingly are somewhat graded relative to each other. So you get the sense of some basic questions and a sense of some sort of higher grade questions, or should I say tricky questions. Now folks, what is important in all of this is not just to be entertained, okay? Or think that by watching you know what to do. Remember, when you see someone do something, it looks easy. But when you have to subject yourself to doing this thing yourself for the first time sometimes, it becomes very, very scary. It's a very daunting kind of a situation. So just learn so that you can gain your independence in solving these problems. By learning the tricks, especially knowing how to milk information from the question, analyze it and place it somewhere in your knowledge, and then of course see what clues are there which prompts perhaps a particular technique or an idea of how to go about solving the problem. Anyway guys, we're going to talk and talk and talk and talk. So instructions cannot be overly emphasized. Students need to know that it's important to read these instructions carefully. That's the most important. Okay. Now, we know, folks, that we can read all of those and you understand exactly the implications. I'm going to take you to the main ones. If ever we have to determine an answer, we need to show all the tools that we have used, including those that you may not think actually apply. This is mathematics. Even a concept from paper 2 can be applied here, and from any topic for that matter. Okay, so the issue of rounding off is also key in getting full marks. Here we're just doing 2 decimal places, and that's all. Okay. That's the essence of it all, guys. Let me just not waste time. Now, this is algebra. This is what I want, because there can't be a maths exam that does not have algebra. It's dangerous. Okay. Question 1. We are told to solve for x. So you guys are familiar with this kind of question. 1.1.1. We've got 3x minus 6 into x minus 5 equal to 0. So obviously students know here that x is going to be 2, or x is going to be equal to minus 5. Please ensure, guys, you've copied the question correctly. Now, I will say this, guys, get into the habit of checking these answers by substituting the solutions to the original equation. And what are we looking for? The left-hand side with the substitution must equal the right-hand side. So usually with equations, you get to know if your answer is correct or not. Let's put it 2 where x is. This is going to be 2 times 3, which is 6. 6 minus 6 is 0. 0 multiplied by anything is going to give us 0. So we know that the left-hand side equals the right-hand side. So that answer should be correct. If we put a minus 5 in the second bracket, that's going to give us 0. 0 multiplied by anything on that other bracket will still be 0. So this means we did not make any mistakes. Remember, folks, when a question is too simple, it's easy to take it for granted. As a result, you commit unforgivable mistakes. So check answers. That way you already know as you walk out of the exam exactly how much you got. Right, the second question says we need to solve this correct to 2 decimal places. This is already indicating that the solutions here are irrational, okay? So we cannot factorize. But I think we need to move away from this instruction because this instruction is for grade 11s. We need to move away at grade 12. A student needs to decide for themselves what to do. Okay, so this is 7x squared plus 4x minus 9 equals 0. So here we're already given a clue that we're going to use our quadratic formula. Okay, so know these guys by heart. Okay, don't rely on the formula sheet for these things. Only get there if you're feeling under pressure and perhaps everything is just not gelling. When you're scared, when everything is just fuzzy, only then must you check these guys. Otherwise, let these things be in your head. In grade 12, you are not to make any excuses. Okay, folks, so from here on, we're going to get our solutions. I don't see the point of simplifying what is under the square root sign at this stage because it is immaterial. But of course, do what your teacher teaches you, but just know in the exam you don't have to do that, especially when you're doing exams like the national exams. Perhaps the class test, you may have to really stick by your teacher's rules because they are the persons who are going to mark your script. Okay, the first solution is 0.88 to 2 decimal places, or x is. Please, folks, make sure your substitutions are on point. There's nothing as criminal as coming up with a wrong answer when using a calculator. So this is minus 1.46 to 2 decimal places. Remember, we have been given an instruction. Sometimes the instruction can say 1 decimal place against the general instructions. Now, folks, as I said, please check that the left-hand side equals the right-hand side. But now there's a special case here. We round off to the nearest integer. Or you can say whole number. So that's just the special case here because we rationalized the solution by rounding off. So when we substitute this back, we need to round off to the nearest integer, seeing that the right-hand side is a whole number, okay? Or it's an integer. 0 is actually an integer, so don't undermine that. It's both a whole number and an integer. Okay, let's do that. So we've got 7 into 0.88 all squared plus 4. Plus 4 into 0.88 minus 9. Now the answer that we got when we round off to the nearest whole number or integer, that is 0. Okay, that's very important. Okay, please guys take these notes down because some of you like to struggle unduly because you don't know what to do. You've not been shown these things. Some of you only rely on being shown these things. You don't develop an inquisitive mind or even one that can see things for themselves. You know, one of my textbooks, back in grade 9, standard 7, the textbook for maths that we used said, see for yourself. It encouraged one seeing for themselves rather than always waiting to be told. Right, when we do this again, the nearest whole number is 0 for what we get. So we can accept that what we did is correct. This already emphasizes that our substitutions are correct. And that's how we score the 3 marks. It's just for substitutions. Don't waste time simplifying that expression under the square root. But if you want, be my guest. All right, so we've got an inequality. We've got 3 minus x into x plus 7. This must be less than 0. Now here the examiner made it too easy. So already, folks, if you think about it, this is minus x times x. This is going to give us minus x squared. Now minus x squared has a negative coefficient, right, which is minus 1. So this is a grumpy face parabola. So we can use the graphical method to solve here. But of course, I always try to do what I call near perfect sketches, because I believe in doing something rather almost perfect than less perfect, because it catches up with you in the long run if you learn bad habits. Okay, so we know that our parabola, the solutions, or what you call critical values, when you equate each bracket to 0 and solve, we're going to get minus 7. Now let's see, where will our turning point be? Will it be to the left or to the right? Now we need the middle term. So the middle term is going to be minus 7x plus 3, which is going to be minus 4x. Okay, so with the middle term being negative and the first term also negative, this clearly tells us that our turning point is going to be to the left. So when we draw a parabola, it's going to be stuff like so. Right. As you can see, I'm attempting perfection, guys, so that I do not overly look certain things. So this is minus 7. This is going to be 3, isn't it? Yes. And I know for a fact that my y-intercept is going to be positive and the turning point is slightly above that. So this is a good sketch. Now, when do we see the graph negative, or at least below the x-axis? We see it here. All these x values will give us negative y values. The same here. This is what's going to happen. Okay, our minus 7 is gone, so let's put it back. It's over there. So we can see that, okay, our solutions, remember this is not included, so this means we can put an open circle and go in that direction. I'm just doing too much at the moment, but yeah, you get the idea, and we go in that direction. So this means that our x must be less than minus 7, or x must be greater than 3. That is the solution. Right, and we know that x, sometimes I add this, x must be an element of real numbers with just those restrictions. I know this doesn't seem to be favored so much these days, but yeah. Now let me show you the second technique that I believe students need to know how to do, especially when you get to functions. You will suffer if you don't know this. So 3 minus x, then x plus 7. So we call it a table of signs, or whatever you may want to call it. I never really knew the name for this, but every now and then I just keep developing ideas. Anyway, there's nothing wrong in being a bit imaginative, isn't it? Because we have to grow our imagination, guys. So what are we doing? It's a product, because those two binomial factors are being multiplied. Now we list our critical values in ascending order, just like you would in a number line. We ask, for the first binomial factor, when would it be 0? When x is 3. So we know that it is 0 over here. When will it be or what would be the sign of that factor when we put a value greater than 3, put a 4, the answer becomes negative. Now, once you establish a negative and 0, you know that this is a linear expression, so the other side must be positive. We go to the second one. When will that binomial factor be 0? When x is minus 7. When, or what happens when we put a value between minus 7 and 3? Just choose values out of convenience. 0, for example, we remain with plus 7, so this is positive. Now, once this is positive, seeing that it's a linear factor, or it's a binomial linear factor, so we know that one side should remain positive. But if we've got 0 and one side being positive, the other one should be negative. But you can check values if you want. Now, what are we doing? We're saying that binomial factor is being multiplied to the next. So we will multiply the signs. Positive times negative is negative. Positive times 0 is going to be 0. Positive times positive is going to be positive. 0 multiplied by any number is 0. Negative times positive is negative. Now we know our solutions are going to be here. The critical values are our yardsticks, or should I say they give us the direction. Now, are we shading those little circles? No, because 0 is not included. But now we want the negative side, so we're going this way and that way, because this part right here is what helps us to read the solutions. So from here, guys, we make the same conclusion as we have over there. Please master these two techniques. They will save you a lot of pain when it comes to functions, because you don't necessarily have to see those things in the graphs, but you may just do an algebraic way of solving. Oh, too fast. So 1.1.4, we've got 3 root x plus 3 minus 5 is equal to x. Now these are radical equations, or you can call these quadratic equations in set form, because there's hidden quadratics here. Now folks, the first thing that we do, we isolate our radical, isn't it? We can isolate it with its coefficient to avoid fractions. So this is going to be equal to x. We transpose the 5. It becomes positive. Please don't square on this step, square on the next step, because the first step here was to do an operation which is to isolate the radical. This next step, it's when we do yet another operation. This is essentially what we call an inverse operation or reverse operation. This is essentially what we normally do. Now we know that for a fact, essentially, the square here will square the 3 to 9. Then what is under the square root comes out as it was. This is a trinomial. We expose it. So this is x squared plus 10x plus 25. Now we FOIL, or we distribute. So this is 9x plus 27 equals x squared plus 10x plus 25. Now we write our quadratic in standard form. This is x squared. 10 minus 9 is going to be plus x. Then we're going to have 25 minus 27 is going to be minus 2 equal to 0. So let's bring you closer. Don't be too far away. So this implies now we can factorize this. If you're not sure about factorizing, check the discriminant quickly. If it is a perfect square, it means you will succeed in factorizing. Okay, so that is as simple as that. And if you're not familiar with factorization, just know this is long division. Okay, good. So what do we see, guys? Here we can see that x is equal to 1, or x becomes minus 2. Now here the check is mandatory. It's not a matter of you choosing to do it. It is mandatory because some solutions may have to be rejected. Some solutions may have to be accepted. Now the checks here are in two formats. We check that there is no negative under the square root. Right? The second thing, we check that the left-hand side is equal to the right-hand side when we substitute our x values. So please, guys, take note of these things. They hurt if someone is not careful. Of course, usually this is the main one that often happens. You will hardly see this one, but at times it can be very important to consider. Right, now let's put a 1 in the original. By the way, the check is run on the original equation, provided you have copied it correctly. Now let's put a 1. So this is going to be 1 plus 3, 4. 4 square root of 4 is 2. 2 times 3, that's 6. 6 minus 5, that's 1. And then there's 1 on that side. So this one is good. Right? Then we check the second one. We put a minus 2 there. Minus 2 plus 3, that's 1. Square root of 1 is 1. 1 times 3 is 3. 3 minus 5 is minus 2. And there's minus 2 on that side. So also this one is correct. Okay. Sometimes one is correct, the other one is wrong. Sometimes they both become correct, as it is the case right here. Now, when you are sure that your answers check out, you close with a line like that to show that your solution has ended. All right, folks. So how many marks was allocated here? 5 marks. So we already have 2 marks. Whenever we factorize, we get a mark showcase. You can say here for the method, that's the 4th mark. Then the issue now could be either here doing the right thing or writing the quadratic in standard form. But I think because this came out of a lot of things, squaring this, rearranging and solving, so most likely the 5th mark should be given for that quadratic in standard form, provided it is correct. But then let's say you got this one wrong. I would perhaps consider a mark for you for knowing the method in the first place, because as you can see, I put asterisk where this mark can actually go. All right, folks, I hope this is clear. Now, these are just grade 11 questions, which the manner in which these are asked, I don't like them for grade 12s. We should be challenging grade 12s a bit. We can't have grade 12s having it so easy. But hey, sometimes you can do with a little bit of ease. Okay, so solving for x. Now we know that simultaneous equations are upon us. Please, guys, I want you to really master this technique of simultaneous equations, because it will save you a whole lot of problems going forward. You will see that most of the higher grade questions actually involve simultaneous equations. But when you see these, they will not be so obvious, because first you have to derive an equation or a system of 2 equations mainly, sometimes 3, and then you solve simultaneously, and then you get the answers. So this must be one of the sweetest techniques a student must ensure that they can dream about even when they are asleep. Okay, so that's very important to do so. Okay, guys, we're given equations y equals 3x plus 2. This is as good as equation 1. Then the second equation is 1 over y plus 3 over x equal to minus 4. Right, at this stage, we can sort of modify this if we want. I think let's just leave it as it is. Okay, there's no problem. Now, folks, we can see that we've got y and we've got y. So we can do the substitution method. So we are solving here by substitution. Now remember, guys, to do simultaneous equations, there's 3 methods that one must consider. Sometimes there's only one of the 3 methods that can work. So you may have substitution, you may have elimination, you may have comparison, I suppose. So usually when you've got a single equation with multiple variables, single equation, or sometimes separate. Okay, maybe let's not say a lot because we're gonna mislead people. Sometimes you just solve by comparing certain things. This is one of the killer techniques because sometimes it's the only way you can solve a particular problem. Sometimes elimination is the only way, sometimes substitution. So please know these things. Know these things. They are very important. They are very important. Okay, so now we're going to take, say, put 1 into 2. Okay, such that what are we going to have? We're going to have 1 over, where we see y, we're going to put 3x plus 2 plus 3 over x equals minus 4. Since we are dealing with fractions, we might as well write it like that because an integer is a rational number, isn't it? Now, folks, we're going to use the concept of LCM. This means lowest common multiple. Please don't say LCD. There's no such a thing called an LCD. That's a misnomer in maths. We only have a common denominator or an LCM. In fact, if you want to say more about the common denominator, you can even say the highest common denominator, because of the denominators at hand, you always choose the highest one. You don't choose the lowest when they can go into each other, especially the smaller one going into the bigger one. Hence, I would say the highest common denominator, but rather say the common denominator to cut the nonsense. All right, but technically, it's an LCM. Never ever use the term LCD. It's absolute rubbish. Okay, so what are we going to do with an LCM here? What is our LCM? So an LCM is going to be the product of the denominators when they cannot go nicely into the bigger one. For example, x cannot go to 3x plus 2. It only goes to 3x. So that's going to make it difficult to choose that denominator. But 1 can go to x, it can go to that whole thing. But because x does not go nicely into the whole thing, so we just take the product of all. You're going to say 1 times x times 3x plus 2. So we end up with an x into 3x plus 2. That's our LCM. And we're going to multiply by it throughout. So what happens when we do that? So we're going to have 1 over, let me just be careless at the moment and just show you everything so that you understand. So we're going to multiply this with x into 3x plus 2, right? Plus 3 over x. I'm just being silly at the moment. Again, we're going to multiply this with x into 3x plus 2. This is going to be equal to minus 4 into x into 3x plus, I'm right at the edge. Okay, let me just push it back a bit. You see, fractions, I like rational equations because this is essentially a test of whether you've learned anything in the previous years. So this is x into 3x plus 2, right? Okay, there we go. So this is what we are doing. I just wanted to show you what happens so that you can see that you no longer need to do this physically. You can do it in your head. Just close this denominator, then you multiply by this to the numerator. You close that, you will be multiplying by that to that. And this one gets both because there's nothing. Okay, so this will happen. That's just what I wanted to show, guys. Okay, this implies, now when we take 1 and multiply x, what happens? We just get x plus. Then here we're going to have 3 into that, so we FOIL it quickly. Let's not waste time. So this is going to be 9x plus 6. Okay, this is equal to, we do the same here, minus 4 times x is going to be minus 4x. Minus 4x times 3x is going to be minus 12x squared. Then minus 4x times 2 is going to be minus 8x. Okay, so nice and easy, guys. Pay attention. So we can see this is quadratic, so we move everything to one side. We get 12x squared. And then 9 plus 1, it's 10, plus 8, it's going to give us 18x. Then plus 6 is equal to 0. Now we can see that 6 is the highest common factor in all these terms. So we can divide by it. We get 2x squared plus 3x plus 1 equal to 0. Always try to reduce this as much as you can so that the factorization becomes painless. Now we're going to have 2x, x, everything is positive, right? Does it work? Yes, it does. So that's easy. Most likely, whenever you see this, factorization is going to work. But when it doesn't, use the formula. And you know how to gauge. So we can see that x is going to be minus a half here. Or x is going to be minus 1. Now we substitute this one into the easiest of the two, which is equation 1. We can see that y is going to be 3 into minus half plus 2, or y is going to be 3 into minus 1 plus 2. What is this going to be? So we've got minus 3 over 2 plus 2, which is going to be just minus 1,5 plus 2, that leaves us a half, right? 1.5, isn't it? No, it's 1/2, sorry. All right, so this is minus 3 plus 2, which is going to be minus 1. Okay, so these are the solutions. Right, now remember, guys, we don't run. Check if the equations balance. Now, check onto the original. The easiest is this one, so don't sweat. Now take the set of solutions as it is, x and y, and substitute into the equation. Take the set, the second set, and check. If the left-hand side equals the right-hand side in that equation, provided it's correct and it's not manipulated, then you know you are good. Now let's do the check. So we've got a half on the left-hand side. We put minus 1/2 here. So this is going to be minus 3 over 2, which is minus 1,5. Plus 1 is a half. So a half equals a half. So this is good. Remember, guys, mistakes can occur and things can check out. Make sure everything is good. Now we can already see here that if we put a minus 1, it's going to be minus 1 on both sides. So this is good. Now the method of substitution, where did we do it? We did it here. So usually that's as good as it gets, okay? The rest is not important at this particular point. So we've got our 5 marks and we are moving. We are moving. Now let's look at 1.3, that dreaded question in metric. Okay, so we're told that if 2 to the exponent x divided by 16 equals 3 to the exponent y over 3, we now have to find the value of x plus y. Now these are the types of questions where you don't have this continuous calculation from start to finish in some stepwise format. This one becomes a bit discontinuous because some deductions have to be made. If you heard me when I talked about solving simultaneous equations by comparison, obviously here we need to solve for x and we need to solve for y. Can you see? There's two variables in the same equation. So there's only one way we can solve it. It's by comparison. Otherwise, we would not win. Okay. Unless we can find a way of splitting those solutions. But in a way, we do split them. And we do so because of what we have seen and what we compared. So now let's see what we can do here. 2 to the exponent x divided by 16 equals 3 to the exponent y divided by 3. Okay, the gymnastic of choice is cross multiplication under such circumstances. So this implies that we've got 2 to the x times 3, can say to the 1 equals. Now this is going to be 3 to the y times 16 is nothing but 2 to the 4. I'm only changing it because I can see 2 to the exponent 4. Now, do you see, guys, if the left-hand side is equal to the right-hand side, and we've got a power of base 2, then there's a power of base 3, power of base 2, power of base 3. So this already tells us that this guy must be equal to that guy for them to be equal, as well as this guy must be equal to that guy. Otherwise, there's no other sensible way they could be equal, or the left-hand side would equal the right-hand side. It can only happen if the powers of 2 actually are equal, as well as the powers of base 3 being equal. So you can say this implies that 2 to the x must be equal to 2 to the 4, and 3 to the y must be equal to 3 to the 1. Therefore, we see that x is 4 and y is 1. Now, can you see this one? We have to jump into some other story now. You can say then then x plus y is going to be equal to 4 plus 1. Which we can say, therefore, x plus y is 5. Please, guys, have some patience and have some planning. This one is one of the easier questions to answer, honestly. Sometimes it's not so easy to answer this particular question. Okay, so now we are done. So technically, guys, for this and that, we get our marks. How many marks was this for? Really? Okay, this one and that one. Remember, this was a means to an end. It was not an end in itself. Because someone can choose to scaffold questions here to make this completely standard grade. Can say solve for x and y, and then later on and say what is the value of x plus y, which would be ridiculous. It's a lower grade question. So kind of created that question which fits between standard and higher grade. Okay, I hope we are good. Now, folks, we are finished with our question 1. I want to highlight a few things to you guys. Now, let's look back at the quadratic equations. Let's look back at these two. Now, this is when I play, knowledge now. Guys, knowledge has to be appreciated. Now, we're going to do something about those questions. Now, I'm just adding. This is now extra questions. Right? The extra questions relating to 1.1, we can say, first, comment on the nature of roots in 1.1.1. Very important stuff to notice, guys. Now, students, this is what I'm trying to show you now. This is what you can do to get yourself into a very solid position in this subject. Unless you want to be weak and just find luck every now and then, okay? But if you want to make your own luck in mathematics, you need to understand it perfectly. And remember, certain things are taught in a disjointed format or separately. So you don't see sometimes if they actually apply in all of these things. Now, sometimes you may be thinking, what are roots? Roots are what we sometimes call solutions to an equation, right? We call these solutions. And this is when the equation is equal to 0. One side of the equation must be equal to 0. Very important. One side of which is equal to 0. Now, these are the notes, guys, I would rather you take down. Sometimes we call these things, when it comes to functions, these so-called roots are nothing but the x-intercepts. Okay. Now, you need to know this. You need to know this. Okay, so roots, we can sometimes consider them as x-intercepts because this is when the value of an equation or a function is 0. Okay, or we can say one side of the equation must be 0. Then we focus on the expression on the other side. Then the solutions, therefore, would be regarded as roots or solutions, or in terms of functions, we call them x-intercepts. Now let's comment. What is the nature of those roots? So what do you see? For equation 1.1, we saw 2 and minus 5. First of all, we can see that those numbers are real. Those are real numbers, isn't it? Yes. So the roots are real, right? Second thing, those numbers, we know that 2 can be expressed as 2 over 1. Now, meaning 2 can be expressed as a fraction of integers. So this is what we call a rational number. So basically, we know that minus 5 as well can be expressed as minus 5 over 1. That's a ratio of integers. So essentially, they are real and rational. Okay. Now, the other thing that is very obvious, minus 5 and 2 are not equal, so they are unequal. I'm just going to write the symbol this time. So the roots are not equal. They are real and they are rational. So we can stop there. Okay. Now the second one, we can also do the same and say comment on the nature of roots 1.1.2. Now let's give an answer. Let's go back and have a look at 1.1.2. What do we see? 0.88 and minus 1.46. These are real numbers. So first and foremost, they are real. Secondly, what do we see? We can see that essentially, as real as they are, we needed to round off. Yes, when we rounded off, we sort of rationalized, meaning because we can now express these as a fraction of integers, but remember, we rounded off. So we go back to exactly how it was originally. So these were non-terminating decimals. So they are irrational. Okay, the last thing, we can clearly see they are unequal. All right, so that's good. Sometimes I use this. Right, so I hope, guys, you can see that sometimes you give yourself a chance, you learn something. Now we can close this business over here. So you can already see that once you look at things, sometimes it's an obvious issue, but that never really crosses your mind because your subconscious just shuts it off, because even your aware state of mind is only going to focus on the, what seems to be important, but other obvious things which are in the background you tend to miss. Because when you study this, you just focus on solving. You don't focus on analyzing what you are doing. Why am I doing what I'm doing? And what have I got at the end after what I have done? What can I say about it? And you see, this is when you see yourself really shaping up into a maths student. Okay, guys, let's move on to the next question. Let's not sit too much. So question 2 says, given the sequence, calculate the values of x and y. I like this question the way it is asked, okay? If the sequence is arithmetic. Okay, that's good. So at 2.1, we are given a sequence which we don't know what it is. So this is 81, x, y, 3. And it doesn't seem to continue, it stops there. Now at 2.1.1, we're told that we're dealing with an arithmetic sequence. Now in an arithmetic sequence, there's a common difference. So we know that essentially x minus 81 must be equal to y minus x. Right, now we can see there's two variables here, so we're in trouble. We need two equations. Okay, cool. Let's first sort this out. If we move x to the other side, we get 2x equals, we move 81, it's going to be y plus 81. Okay. Okay, maybe we can leave it at this. This is equation 1. We know that also y minus x must be the same as 3 minus y, isn't it? That's still the common difference. This gives us d. And remember, d is the same everywhere between any two consecutive terms. So what are we doing here? Well, we may want to isolate our x if we want, or we can isolate y. Maybe let's just isolate y. I think it's best to do x. So we can say here, therefore, maybe we can conclude there as well. Therefore, x equals, remember x comes this side, and everything else goes that side. It's going to be 2y minus 3. We make this equation 2. Now the good thing is that we're going to say put 2 into 1. Great. So what do we see? 2, where we see x, we put 2y minus 3. And then what do we have here? It's going to be equal to y plus 81. So this implies, we FOIL, this is 4y minus 6 equals y plus 81. Move everything to one side. This is going to be 3y equals 81 plus 6 is going to be 87. Nah. Yeah, therefore y is equal to 29. Nice and easy. So this would also mean that x is, now let's substitute into, the second equation is going to be 2 into 29 minus 3, which would be 55. So those are the values of x and y if the sequence is arithmetic. Now, do you see simultaneous equations have had to kick in here? And you least expected them. So this is why I was saying, please guys, every technique you will see in algebra applies everywhere else in maths. And this time you were not told you're going to do that. So they didn't ask you derive an expression in terms of x or derive an expression in terms of x and y, then solve simultaneously. You're not asked, you're not prompted, you are expected to know what to do. As I often say, question 1 is a warm-up question. Question 2 is a serious business, okay? So folks, I will say, well, we get a mark for these two because that's what we want. And then the technique of solving simultaneously. Then we can say for deriving the two equations, because at this point we are not given more marks. Technically, this is a 5-mark question, but yeah, whatever. So can you see, guys, simultaneous equations have become your problem if you didn't know. So 2.1.2. By the way, wait. We need to check that if we really did this, would the sequence make sense? This time the check is no longer about the values of x and y. Let's check if now the sequence is making any sense if this is to be arithmetic. Let's just write it here. Sequence, it's going to be 81, x is 55, y is 29, and then we've got 3. Does it make sense? Do we have a common difference between these two? Let's see. 55 minus 81 is minus 26, right? 29 minus 55 is minus 26. 3 minus 29 is minus 26. Yes, indeed. This is an AS with A equals 81 and D equal to minus 26. So the check is complete, that indeed our solutions could not be wrong. They can't be wrong because they are sensible in terms of the information given to us. Okay, so can you see, guys, certain things check out in a different way, because if our equations were faulty, checking those equations is going to give you a false impression that this is correct, only to find that it doesn't work out that way. Okay, so now if this is geometric, what do we know? There must be a common ratio between any two consecutive terms. So we know that x over 81 is equal to y over x. Again, we've got two variables, so we know that we're going to have to cross multiply. So we know that x squared is going to be equal to 81y. We can leave this one as it is. Say this is equation 1. We know also that y over x should be the same as 3 over y, right? And of course we cross multiply there, cross multiply. What happens? We get y squared is equal to 3x. Okay, so what do we do now under these circumstances? Well, we can do something about it, but I think it's best to isolate x here. We can say therefore x is going to be y squared over 3. We can make this equation 2. Now we're going to say put 2 into 1. Okay, and what do we get? We get, where we see x, we put y squared over 3. Then this is to be squared is equal to 81y. Now let's sort it out. This is going to be y to the 4 divided by 9 equals 81y. Now this is 81y over 1. But anyway, let me do it this way. Okay, I don't like it. I don't like it. I don't like it. I don't like it. But let's see what happens. I was thinking of something else. You know. But anyway, let's just cross multiply. Stop hesitating. Sometimes when you've got multiple options, this is what happens. Y to the 4 is equal to 81 by 9. That should be 720 some change, right? Yeah, 729 y. Okay, let's continue on this side. So sometimes when you run out of space on your page, just draw a vertical line, because it shows that you are moving over to the other side, but don't move up there. But you can make it longer if you want to, but it's nice to work close to where you are. Okay, so what are we going to do now? We are going to move this over to the right hand side. So we have y to the exponent to the left. By the way, my left is my right, 729y equal to 0. Right. You get it. So the highest common factor. So we get y cubed equals 729 equal to 0. So we can see that y is either 0 or y cubed is equal to 729 is 9 cubed, isn't it? Yes. Of course, when you use your calculator, this one is going to sell you out. 729 shift fact, it gives you 3 to the exponent 6. Okay? But you know that 3 to the 6, you can just split it into 3 cubed. Ne? Wait. Ndifuna iphumela 9, man. It's gonna be 3 squared. Oh, my leg is cramping. This is gonna be 3 squared. Abamsebenzela ebhedini kuyabheda. Hayi masiyeke. Anyway, ndiyayazi binje apha. Yabona mas, because 10 with 9 times. The reason I know is because not so long ago we did something about it. Khona into besiyibalile no 9 times 7. Asakhumbula biphi. But yeah, siyenzile. So this is the one, guys. Because 9 cubed is 729. So we can say therefore y is either 0 or y is equal to 3. 9. Yawena. Same exponents, we equate the bases. Okay, so although that equation tells us that we've got a quartic equation, we expected, somewhat a large number of solutions, but no, they are not. Okay, so if that is the case for y, what is the case for x? We can say therefore x is, now we put 0 there, everything is 0, isn't it? When we put 0 there, everything is 0. But now, is it possible for 0 to be here? Now, let's think about it, by the way. Is it possible? Because this conclusion is ridiculous. That's another question here that you need to answer. Can y be 0? No. Why? Because y is in the denominator when we determine the common ratio. So, we cannot divide by 0. So, technically, essentially, y cannot be 0. Can you see? These questions I love because they keep you awake. You can be so careless if you don't understand what you're doing. Already, knowing that y should be in the denominator when I want the common ratio, it cannot be 0. So essentially, you see, I got caught pants down. This is the conclusion. Y must be 9. It can't be 0. Nice. So we can forget about 0. Now let's say y is 9. Now 729, what is a perfect square, I think. Yep, let's see. Square root answer. Yes, it's 27. So we can see that x is going to be 27. But remember, For x, it was a plus and minus. Now the question is, can it be negative? That, my friends, is doing its own things. Ne? Yeah, it's doing its own things. Technically, it can't be negative, because if y is positive, and we see all the other terms are positive, it's a must that it becomes positive. It can't be negative. Can you see? Here, guys, you need to think about your answers. I love these questions. This is how sequences and series should be really examined, not calculate the first term in an arithmetic. Come on, get away. Go away. All right, guys, so these were beautiful questions, and we have revised these in class, guys. And as I said, we need to master checking our solutions whenever we can, because that way we know we've gotten everything in the bag. Right, folks, so substitution technique, yeah. Answer for x, answer for y, yeah, 3 marks. The 4th mark is deriving these two equations. Remember, deriving is to come up with an equation. To differentiate when you do calculus, it's actually manipulating that equation so that you can get the gradient function or the gradient. So do not say when you differentiate you are deriving. No, you're not deriving. You are differentiating. Although you're going to get a new equation, but you have done something rather specific in terms of, algebra, rather than doing something general and coming up with an equation because of the relationships. Anyway, guys, those are just technical terms. Now let's run a check. Will our sequence make sense? Let's say we've got the sequence. It's going to be 81, not equal to, but the sequence 81. X is 27. I man, hey, 27, 9, 3. Now let's check. Do we have a common difference here? Let's say A is 81. What is R? Well, 9 over 27 is a third. 3 divided by 9 is a third. 27 divided by 81 is a third. So R is 1 over 3. So yes, 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 yes. Iphumelele ngenkanyezi ezinhlanu. 5 stars. It's good, it's nice. Okay, guys, so I hope you are learning. I really hope you are learning. Okay, let's move on. Still have a lot of work to do. So let's do 2.2. 2.2 says the first 4 terms of a quadratic pattern. Always pay attention to what is given. So we know that we've got a QS, which is 661, 591, 525, 463, and it goes on. So if it is a quadratic, we don't wait to be asked anything. We sort out the first differences. 591 minus 661. This is minus 70. Right? And then we do the same thing here. We do the same thing here. So 525 minus 591. This is minus 66. Sometimes do this with your head, students. But sometimes it's going to take you time, which you don't have in the exam. 463. Remember, in the exam, it's a matter of efficiency by the student. So the calculator can assist in achieving that for you. Okay. Right. So this is the story. Of course, guys, this is a sequence of first differences. Now there will also be a constant sequence of second differences. Now we can see here minus 66 minus 70 is like 4, right? Right. So this one is 4. And it would go on in a constant manner like this. Let's just confirm it, guys. Sometimes it's easy to make an error without noticing. Yes, we are good. Now let's see, what are the questions? 2.2.1 says we need to find the nth term. This is now a grade 11 question, guys. It should not be here. Please stop asking grade 11 questions in grade 12. We are not interested, okay? Please. For me, the second question should be the first question that is asked, if at all, the only question that should be asked. We can't have that first question. That one is an insult to a matriculant. We can't just give marks for free, guys. No. You either fail maths or you pass it. You can't be gifted marks. You cannot be gifted a pass in maths because you'll get wrong ideas about yourself. Okay, anyway, leave my nonsense. We know that 2a is going to be 4. Therefore, a is a plus 2. We know that 3a plus b, now a is 2, plus b should be the first difference, minus 70. Therefore, b is going to be 6. That side is going to be minus 76. Okay. This implies a plus b plus c must be equal to 661. So a is 2 plus b, which is minus 76, plus c should be 661. Therefore, c is what? Let's find out. 6 in. This is going to be plus 74. This is 735. So therefore, t sub n is 2n squared minus 76n plus 735. Okay. And please guys, check. Now what do we check? We check that the formula is representative or represents the whole sequence. Okay, so what you check here, because everything would look okay if you check it locally, but we check whether this sequence comes up every time we substitute the term position. Now, I often choose non-contiguous terms, or terms that are not next to each other, so that I can be sure that this is not lying to me. Because when I check the ones next door, they might lie to me. I have seen that happen, okay? Right, now we've got 2 into 1 squared minus 76 into 1 plus 735. 661. Good. The first one checks out nicely. Now we're checking term 3. It's 525, so that's good. So only when you can be sure that definitely my sequence is the one, then you know this is good, because you can get a nice answer. The first one checks out, you find that the third one doesn't. Then that means it's an incorrect formula. Okay, guys, so we get a mark for these determinations and then putting it together. So easy 4 marks, which is actually a gift, honestly. I suppose examiners are just trying to prevent you guys scoring 0 in a maths exam, which should happen actually. If you don't know enough, you should fail dismally. In fact, get it under, you'll fry usually utyebe belivila ngaphezulu. Right, calculate the value of the lowest term. You see now we want to hear these terms as the lowest. Which one is this? Remember, this is a quadratic expression. Now, this is a quadratic expression, but remember the coefficient of the highest power is positive 2. So what does this mean? We know that a is greater than 0. So when a is greater than 0, when we were to draw this on a Cartesian plane, this would be a smiling parabola or a concave up parabola. It has a minimum value at the turning point. So do you see And what is the value here is the y value. So this is the Tn value at the turning point. So whether in grade 11 or in grade 12, you can answer this question. For grade 11s, this is a higher grade question, but for grade 12s, this is a standard grade question. Okay, just know it. So we know that Tn, because we want the value of the term, not the position. They didn't say which term is the lowest term. Now we know that, okay, if we want the term, the y value at the turning point, this is 4ac minus b squared all over 4a. This means Tn, this is 4 into a is 2, c is 735 minus b squared is minus 76 squared, all divided by 4 into 2. You can say therefore Tn is, now we've got fraction 4 into 2 into 735 minus into minus 76 squared to 4 into 2. We get 13. Nice and easy. Okay, so guys, you just have to know. You just have to know. But do you see, you only know from an understanding standpoint. Otherwise, you are dead here. You wouldn't know what to do. Now, let me show you another technique that students need to know. First of all, we're getting 3 marks. So here we can say, find substitution answer. This time, you get a mark for this formula because it's not so obvious that you could use it. Yeah. Right. The other technique that students need to know, you take the quadratic formula. You know that T sub n is equal to 2n squared minus 76n plus 735. We also know that Tn would be, we complete a square, we factor the 2 out, we get n squared minus 76 by 2 is 33, right? Is 33n. Uxokile son, 76. Utheni ngixokile nje. Mangangiqheli. Izoba ngu-16 ku-8 man. Yes. 38 man. Yewena man. Plus, now let's just sinikeza inkinga because it's an odd number, this one. Let's see what 735 divided by 2. Yeah, it doesn't do the things. Anyway, we're going to write it as it comes up as, you see. Don't panic when it doesn't go away. So T sub n equals 2. Now we complete the square. We take what is under the square, the original sign. 38 divided by 2. Is it 18? 17. Yeah, I think it's 17. 38. Now it's 19. Thenga le maths ayifuna ukubuya nje. Thenga le maths ifuna ukuqhwesha nje. It's 19 vele. Squared plus 735 divided by 2. Now remember, we immediately subtract that 19 of ours squared because we want to create a balance. Remember in maths, guys, if you've got a plus 3, I can say plus 5 minus 5. This is the same as just adding nothing. So this is a technique in maths. So what I'm doing there is exactly what I'm doing. Wayifundiswe le emva ke lonto. Njengoba soyilibele nje. Tn is 2 into n minus 19 all squared. Plus, is it going to be plus or is it going to be less? I don't know. Let's find out. 735 divided by 2. Subtract 19 squared is nothing but 13 over 2. So we know that T sub n, we redistribute the 2, is going to be 2 into n minus 19 squared plus 13. Do you see that this is the minimum value? From here you just write, man, good. Oh, sendikubonile. You can just say therefore Tn must be equal to 13. the minimum term. You can even say the minimum term, the value of the minimum term, or whatever you call it, or the smallest term. Maybe let me put it that way, the smallest term. The smallest term. Can you see? You can complete the square. Guess what? You get a mark for writing it in the vertex form. You don't get marks for the manipulations because apparently your curriculum refuses to recognize this, but it's actually important. So you get a mark for writing it and then telling us this one. We get 2 marks for the answer. Ne? Yeah. It is like this, guys. It is like this. So this is nice. It's beautiful. It's excellent. So please understand, when you're dealing with sequences and series, you're still dealing with quadratic functions. Think of it that way, where algebraic techniques and function techniques will kick in. Okay. Right. Let's move on. 2.3 says an arithmetic sequence. What is it? Arithmetic is given such that T1 plus T3 plus T5 plus T7 all the way to T2013. This is the answer. Okay, so what is happening here? We are taking the odd terms of the arithmetic sequence and we're adding all of them up and we're getting 329. Also, we've got T2, T4, T6, T8 up until 2014. So we're taking all the even position terms and they all sum up to 60, 50. But now the first question that you want to answer is, how many terms are in this sequence? This is the last term, right? This is the last term because 2014 is bigger than 2013. So it means there's 214 terms here. 2014 terms. Now again, this is an even number because of an even last digit. So this is an even number. But now this is too big. What do? You first work it out and say, look, in general, if I have a sequence, you make it short. 1 plus 2 plus 3 plus 4 plus 5 plus 6, say plus 7 plus 8. Make sure that you take a small little model of this long and big sequence, which is going to cause you problems. You just want to study something small. From this something small, we can gain ideas on how to solve. Now, these are the questions which are true higher grade questions because they seek problem-solving skills from you. Now, you're not going to be able to solve these questions if you don't do what I'm showing you, because there's no shorthand techniques around these problems. Because sometimes you're not sure if what you're doing is correct. Now, this is how you're going to be sure at the same time you are learning on the job. These are the kinds of problems that really put you in the sticky position because you are like someone who's learning on the job. As you go, you learn. It's like an internship program when you become a doctor. The fact that you passed with flying colors, cum laude, if they decided to love you so much to give you cum laude in medical school, because I can tell you for free, most of those cum laudes is because professor that need. If you are the likes of me who challenged those very professors at varsity, they actually hate you and they're trying to prove a point on you and they will not give you a chance to get a distinction. Anyway, that's a story for another day. I will tell you the stories about me and university, but I think I am not a woman. You see, women are the ones that love to tell. Men never tell, so I must not tell. I'm a man, by the way. I forgot that this thing is not to be told. Men don't tell nothing. Yeah. Right, now let's study this thing now. We took these odd position terms. So we decided, okay, we're going to take these terms. First of all, we want to understand. We know that this is a natural number sequence, right? Ending at 8. We know this is arithmetic where the common difference is 1. But now we want to study what happens when we take those three. 1 plus 3 plus 5 plus 7, right? Those are the odd positioned terms of that sequence. Do they lose the signature of the original sequence? Meaning, do they lose their arithmeticity, if there's such a term, or their arithmetic nature, perhaps for a better word? Yes, they don't lose it, because 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. Can you see? The original common difference was 1, but now it just doubles it. But all we know is that these terms still form an arithmetic sequence or series. So we can already see that this is an arithmetic series. It helps to know that when we split these like that, do we lose our arithmetic relationship of these terms? No, we don't, because this shows us. But now let's look at the even positioned terms. Are they going to be the same idea? Now let's take them down. 2 plus 4 plus 6 plus 8. Look at that. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. So essentially, we can see that when we take these odd terms and the even terms alone, they are just related in an arithmetic type of a sequence, but we just such that the common difference is double. Now I want you to take note of this, because this may be useful in some other questions, because sometimes you may be given this theoretical type of a sequence, maybe with letters representing the sequence, and then you have to draw the conclusion of what would be the common difference, if at all we focus on the even terms only. You just know that whatever was the common difference, I double it for the others. Can you see we are studying in the exam to make sure we win instead of losing? Right, so this is also an arithmetic sequence or series. So once we know these guys, we are happy, because if we know what these are, we can deal with these problems. So we know that the sum in an arithmetic series is n over 2 a plus l. Okay. We don't need the common difference because we don't know what it is. And by the way, this question wants it. We need to find the common difference in the original sequence. All right, okay, all right. That's not a problem. Now, what do we know, guys, about terms in an arithmetic sequence? We know that the first term is a, right? Right. So if we go back here into our sequence, we know that this is a. Now the second term is a plus d, the common difference. Nice and easy. Because now these ones are starting in each of the sequences we were given. That's why I'm looking at those. So we've got a plus d, we've got a. Okay. What is next? The last term is 2013. We know that this is going to be a plus 2012d. It always goes like that. Nice and easy. So that is what it is. This one here, the 2014th term, is going to be a plus 2013 times d. So this is what we know. So now we're going to come back here and say, okay, fine. The sum here is 3029 equals, what is the number of terms in that sequence? We don't. Oh, by the way, it is important. I forgot to explore that. So what would be the number of terms? We said they are 14. Now, the other thing we need to study is that when we get an even number of terms in a sequence, when we take the odd positioned terms and the even positioned terms, we will see that out of 8 terms, we've got 4 odd terms, we've got 4 even terms. So it splits into 2. So this means these are going to be equal to how many terms? 2014 divided by 2 is going to be 1007 terms. Right? The same will be the case here, 1007 terms. Okay, guys, so can you see this question? You're not going to win if you don't do your things. That's the one thing that we needed. A is just A for the odd. The last term we saw that it's going to be A plus 12D. Right. Now let's work it out. We cross multiply the 2 there so that it gets out of the way. 3029 times 2 gives us 6058. This is equal to, now this is 1007 into, this is 2A plus 2012D. We continue, we can say therefore 6058 equals, we distribute 1007 times 2 is going to be 2014A plus, now this one icon, I guess is praising mode. Let's see, 2012 times 1007, it gives us 2026084 times D. You can say this is our equation 1. Okay, we can say also, we know that Sn is going to be, okay, let's not repeat the formula now, we've written it above, we can just jump in. The other one, the sum is 6050 equals how many terms? Is 1007 terms divided by 2 into, this time our A is A plus D, plus the last term is going to be A plus 2013D. Okay guys, cross multiply the 2 there. 6050 times 2 is 12,100 equals, this is 1007 into, now A plus A is going to be 2A plus, now 2013D plus 1D is going to be 2014D. Okay, so therefore 12,100 equals, distribute here, we're going to get 2014A plus, the other one is going to be naughty, 2014 times 1007, this is going to be 2028098. By the way guys, do you know how to read these numbers? Of course this is going to be D. Do you guys know how to read these numbers? I wonder how many digits? 1 2 3 4 5 6 7. When a number has 7 digits, in which bracket is it? Is it thousands, hundreds of thousands, or is it millions or hundreds of millions? What is it? It's millions, ne? Yeah. So this is 2 million point some change, ne? Point some change. So this is 2,028,098. Yes. Okay, you can read the one at the top. In case you don't know, you are dead. Now let's compare these two. You see there's a 2014A in equation 2. There's a 2014A in equation 1. So the elimination technique of solving simultaneous equations will be the best suited for the job. Can you see guys, this question teaches you more than anything during the exam. Of course, weak students are going to lose here. Okay, so we're going to say 2 because it has bigger values, minus 1. It's going to be what? 12,100 equals 2014A plus 2,028,098D. Then we subtract that value, 6058 equals 2014A plus 2,026,084 D. Okay, this one is under the bracket. Now we can already see that magic's happened. This will cancel that. That's the first thing. A is eliminated. So let's see, 12,100 minus 6,058. This gives us a 6,042. Now this is going to be equal to, now we've got that 28,098 minus 2,026,084. Yeah, doch. We are doing the things here. So we get 2014 D. So you can already see that D is going to be that value, 6042 divided by 2014. We get 3. Nice and dandy. It's beautiful, this thing, man. It's nice. So you see, guys, if you understand your subject, you can even learn and revise for something that is strange and get it right. Because this is analogous of the question given. So you must draw an analogy, a smaller one that you can handle, then transfer those characteristics to the main question and sort it out. As you can see, it helped us all the way. Of course, with these kinds of questions, you lose a bit of time. This is why you become quick on easy questions like solving for X, but while making sure, though, that you're doing the right thing. But when you get to these questions, this is where you know that some good 5 minutes, 10 minutes can be spent. And I can tell you, don't ignore this just because, you know what, you need to chase the others. You can get a 72. Let's say 77 out of 100, right? Now, if you want a distinction, you should get 80 out of 100 because that's going to be 80%. So you may lose these 3 marks, which was what you needed, and perhaps you could have handled the problem if you just looked at it properly and, of course, spent some time. And the nice thing here, we're looking for the common difference. At this point, I don't care whether it's correct or not. It's done. First is a 1 mark for this, and the technique of elimination here. And then, of course, deriving these 2 equations. Can you see we went through so much pain for very little? Of course, this question deserves more marks than it is actually getting. But I suppose the examiners here, they are trying to protect you from losing too much in case you cannot handle it. And also, they're afraid of sinking your mark. But these are the main questions you should be getting when you do sequences and series. Not these easy questions on the arithmetic sequence that you get. This is the type that should be for matrix. And this question for me, knowing that the number of terms in each sequence are going to be 1007, this is a mark. Maybe let me mark it in a different pen so that you can see that this is actually what was supposed to be given. This was supposed to come up, right? At least the number of terms would matter. The rest doesn't because you can generate it. I think that would be a mark. Perhaps that would be the 4th mark. The individual equations for me, they deserve a mark each instead of combining them into 1 mark. It's not easy to come around those values. So if we count now, it's 1, 2, 3, 4, 5, 6. Yeah, that makes sense to me. This is enough for 6 marks. But yeah, we decided to chop it in half to save those who could not manage. Anyway, folks, that's it for these 18 marks of this question. Now is the time for me to start asking some silly questions. But do I really need to? Maybe. Ah, Lord, have mercy on me. Okay, let me do it. I'm just going to ask 1 extra question, guys. I'm not going to ask a lot. Just one. The question says, which term of the sequence in 2.2 will be the first term to be greater than. Now let me see. Let us see. I have to create a question with inequalities because you guys, you forget these things. Ndiyanazi. Andifuna ucinga, so ke ngizonigcingisa ngenkani. Yeah. Let's see, 2 into andizutsho. Andizonixelela uba ngubani inamba endiyifakile phayana, ndizavele sendivela nenamba qha. Nkosi yam, ilihlo lam libuhlungu ngoku. Why is my eye Aina? My eye must not be Aina, man. Cannot be Aina. All right, this must be great. Sazan 63. Which term of the sequence in 2.2 will be the first term to be greater than 63? It's a question mark, by the way. Now, how do we answer this, guys? We just say, well, Tn must be greater than 63. Tn was 2n squared minus 76n plus 735 greater than 63. 2n squared minus 76n plus. Now, 735 minus 63 is 735 minus 63 is 672 greater than 0. We can divide by 2, so we've got n squared so we will have n squared minus, we saw that this is 3 8 right, yeah, and then this is going to be plus 672 divided by 2 gives us 336. All right, this must be greater than 0. Are we going to be able to factorize? Maybe. If you don't, do your thing. So I'm going to say 336 equal sign. It's going to be 336. And then I shift. And then I fact, okay? So I'm going to go shift, fact. This gives me 2 to the 4 times 3 times 7. Okay, so obviously I think I'm going to have to split that because 16, let's see. If I say 7 by 2, that's going to be 20. That's 21. And 16, it's not going to work. Okay, so I want 38 to come up. Let us see. These are both negative. So 16 plus 21. Let's see, what does it give us? 16 plus 21. 37. Hayi man. Don't ngawe wena man. Kinga wena. Why uzoba seduze? Okay, let's check the discriminant before we kill ourselves. The discriminant is going to be b squared, so minus 38 squared minus 4 into 1. We take the discriminant of that last quadratic, okay? Into 336. We get 100, so this thing should be factorizable. Why the 37, 21 plus 16. 100 is a perfect square, so this is factorizable. Okay, maybe we need to manipulate some things here. Okay, we can do it. We can say this is 2 squared times 3. Then we say 2 squared times 7. What do we see? 4 by 3, this is 12. 4 by 7 is 28. Yes, this gives me 38. Ne. Yawena. Uzawuthi wawuphi? Uzawuthi wawuphi? Xa sasitshaya. Hayi man, ngu-40 nje lona. Hayi kwethini man. Hayi kwethini man. This one is giving me 40 now. Celebrate msinya ne. Yandiqhela ke. Okay, let's see. 8 times 7 is 56. Yes. I say phambeni ke ngoku xa siyilapha. Hi guys, 10 ndazoqala i-factorization ngoyiphambanela xa liphi ilanga. Hayi man, ibona ke ngoku. Okay, maske siqale pha 735. Hayi man, kanti kutheni ngoku? Minus 63. Yes, divide this by 2. Yeah. Then we shift and fact that thing is 2 to the 4 times 3 times 7. Yeah guys, maningaqhelwa kaloku, maningaqhelwa. Mandingaqhelwa. Sengiqhelwa kabi ngoku. Okay. So now what we need to do, we need to split that 4. Hey guys, it's a continuous issue lena ke ndokuxelela. Factorization is work, so we can say 2 times 7 times, and then this is 2 cubed times 3. How to see board? This is 14. This is 8 by 3. This is 24. I think it's ospanale. 24 plus 14. Yewena. Ruqedile rumasutse man. Ono batla hore tena jwale hore etsa diphahlo watawa. They are both negative mos. Yeah. Hey, re masutse ne nahana re tlo hana re sune ntwena. Re tlo suna kankane he. Wa tseba masore rena re basuni. Re hapeletsa ntho e sa batlo sebetsa mona re tlaela hampe. Jwale, oh sorry guys, for those who didn't know, we kissed it by force, ne? We force it by kiss. Right, so let us see what this thing is saying, guys. Let us see. So we can see that n is equal to 24 or n is equal to 14. Does this make sense? Yeah, it does. Because remember, this is a parabola. Now a parabola is going to have two. Is a many to one, isn't it? So now, oh sorry guys, I'm making a mistake. This is an inequality. Where's Android? Parabola is needed. Now remember, drawing a parabola of which expression? The simplified one. Okay, know this guys. So this one, Sunkail. You're not straight, man. I want to show you things, guys, so that you're not weak. Okay, so this parabola is a smiling face, so it's gonna have a minimum value somewhere, so we can do this. But now we see that both thingies are positive, so we can just focus on this side. So we've got stuff like this. Ne? Yeah, we've got stuff like that. So now we know, folks, that this one doesn't start at term. I mean, it doesn't start at infinity. So this part, the y-intercept does not exist. Only term 1 is important. only term 1 right there. Term 1 exists, which we know is quite a big number by itself. We saw that it was 661, isn't it? So this was 661. All right, now the question is, will this graph dip below? No. So this is a wrong sketch. Nonsense, man. Nonsense, man. This graph is big, mas. It's already greater than 0. We saw that the minimum value was 13, which is a positive number. Let's do it. Let's do it again. See, guys. Remember, this is the n-axis. This is Tn. This is 0. So we saw that the thing was doing this stuff. It was not getting to the ground. Hey, sengilibele jwala. Awulibele ke ngoku uzabangibona nini? Kitabaponi ka selemo se tlang wa bona. Hona tjena ke mabele fela. Se tlang sona ke tlo ba keng? Ke tlo ba ke poni. Yeah. 661. That is the one, right? And we saw that this term right here was 13. Don't worry about the disproportionality things. So 13. So this means this one is either here, which is our term 14 as we got it, and then the equivalent of that term is going to be over there, which is term 24. Now, which one is the first? Remember, how do we read the graph, guys? Yes. We read it from left to right. Now, which one is the first to become greater than 63? It's going to be, by the way, it's not equal to, but greater than. So now these terms over here, folks, if you look at it, up to term 1, it's greater. And those ones are greater. So yeah, I created a nightmare of a question. So which term is going to be greater, right? Obviously, term 24 is 63, right? So it should be term 25 on this side. But on that side, this is term 14, so this is 13. Now, as I said, we read from left to right. So the first one to become greater than is going to be term 13. So we can say therefore T13, or in fact we can even write here nicely that n must be less than 14, or n must be greater than 24, isn't it? Now, which one is the first one? We can say therefore n must be equal to 13. That's the first one. 24 is the second one to become greater. Term 25 is going to be the second one to become greater than 63. But the first one is term number 13, which comes before term 14. Now, guys, if you don't learn anything from this, what is going to help you learn anything? Because, hey, guys, yabona na ukuthi akudlalwa xa sithi senza maths. We can create a disaster for you and let you sink into it and die. I hope you've learned something through this question. So I would say revisit this question and, of course, try to follow everything I'm doing and understand why did I choose term 13 instead of term 25. Term 13 is the first. Term 25 is the second to become greater than 63. The question said which term is the first term to be greater than 63. Right. Okay, guys. So as you can see, inequalities will still be asked here. Okay, so let's do the next question. Question 3. Remember, this is a revision video, guys. So don't cry and say you are too slow. No, I'm not trying to be fast. Okay, prove that this sequence or series converges. So if it has to converge, the moment you see infinity, guys, just always think, if you see a sum to infinity, we can only do it. In metric, it is only possible when, when it only is possible when we have a geometric sequence or series. So first of all, guys, you take the sigma like this. This is 7. When you see a dot, it's a multiplication times 3 to the 2 minus k. Always expand the sequence first. K being 0, this is 9. 9 times 7 is 63, right? Plus, the sigma sign means plus. Then we put a 2 there, sorry, a 1 there. 2 minus 1 is 1. This is 3. 3 by 7, that's 21. Plus, we put a 2 there, that's a 0. That becomes 1, so we get 7. Then it goes. So all we need to know here is that R is going to be equal to 21 over 63. You can say therefore R is equal to 21 goes once, goes 3 times. You can say therefore R is less than, okay, we don't write R anymore. I'm going to write a third is less than 1 but greater than minus 1. Therefore, the series converges. How do I know it's a series? It's because there's a sigma sign. If you write the sequence converges, I deduct a mark for being unaware of what is what. Once you see the sign or the symbol, whatever that thing is called, the sigma sign, you know this is an addition, it's a sum. So you cannot say this is a sequence, this is a series, it's a serious business. Right, guys, so this is good. The expansion is key, telling us this thing and telling us the constraint, which leads us to the final conclusion. We don't get a mark for the conclusion, it's suggested, but we need to really justify it, okay? 3.2 says, determine the value of m if sigma of k starting at m to infinity. You can see the general term is the same. Now always try to compare and contrast. Now my students in class, I showed them how to do this. I'm not going to show it again, but just look at this. If this is the same as that, then it means the common ratio would be the same, okay? Now, I showed my students how this works, because if you are meeting this question without seeing the first one, then you need to convince yourself of some things, but I'm not going to show you now. Now, those are going to be the benefits of attending my classes. So we've got sigma of k equals m. Remember, guys, my classes are free, eh? Maybe you guys get scared. You think I'm charging. No, I'm not charging for now. I'm on a what you call a promo. I'm on a promo mode. My classes are free, Buffets. I'm charging loot. I give you quality for free. Call it giving back, okay? Phela ngiyanibona nijaja kakhulu ANC nini. ANC mna, I am a doctor because of the ANC, and I don't care what you have to say about it today. Yes, it's rotten. It's wrong. But guess what? It's individuals in the ANC who are screwing the party up. And you know why they're doing it? Because they have some influences. Remember, you don't see acceleration without an external resultant force. So those fools have an external resultant force that is causing them to accelerate within the ANC. And that's why they're destroying the ANC, taking it to areas it's not supposed to go. But this party, guys, has made lots of opportunities be available to people, even the ones who bash it. The very reason they are even able to have a voice It's because of that party. Yes, it needs to be solved. Something is wrong. And now I can tell you a few things that I have diagnosed about the ANC. It's because it's internal policy. It's public knowledge. So people know how the ANC votes its cadres into power. So it's easy now to buy someone and fund their campaign to become top management in the ANC or to have top positions in the government. Right? Right. And those people, when I bought them, I give them a mandate. This is what you're going to do, comrade, isn't it? Exactly my point. So that's how they're destroying it. Now, if the ANC, look, when those people are implicated in those crimes that they have done, the first thing that the ANC is going to do is to defend its member, right? And this is something that we can say, well, they will defend it as if it's a wrong thing. Think about yourself and your child. Okay, let's imagine you have a child because you're a matriculant. You should not have a child. Now, let's say you are now a 34-year-old, married, with a, say, how old must your son be? It's going to be a young. Let's say you're a 45-year-old. Because if you got your child at the right age, the child would not be enough to cause problems. Let's say your son, when you are 45, your son is 19. The sucker is complicated. He steals in the house. You know it. He steals in the house. And he steals from your neighbors. He's involved in gangs and stuff. Now here comes the community. They want to kill him. Tell me, are you going to hand over your child to the community to kill? You know his crimes. It's not that you don't know. But do you want to tell me that you would hand over your child to be killed, to be necklaced by the community that is angry? Well, here's what I know. Every parent always hopes and prays and believes that their children are going to eventually change, eventually listen. And because of that instinct, you would always defend your child. You will hide your child and say, I don't know him. He's not in the house. He hasn't come back home. You send him far away to try and protect him because you are hoping this maggot is going to become better than it is today. Because people do change, although sometimes it is quite clear when that is hopeless. But God does miracles. So this is exactly what the ANC is doing. I don't know why you always judge the outside negatively, when in fact the very same judgment you're handing over to the outside, when it stares you in the face, you tremble. You find it justifiable to defend, but you're defending a rotten kid. But because you don't think a child is, there's no dustbin for a human being. Let me tell you that. There is no dustbin for a human being, because a human being is dynamic by nature. God can choose to change that sucker into something even way better than he could have been if he just listened from the day one. Look at Saul in the Bible. If at all that story is true, I don't know. But the sucker was bad. He was imprisoning Christians. He was persecuting children of God. But look at him. He is the only person who made the gospel of the Lord spread, if of course that story is true. I don't know, but if you listen to how he spread the gospel, he spread it further than the rest in the Bible. But this was a bad guy, the sinner, who people looked at him and wished God would just rain down his wrath, put the lightning on his face, and then he freezes into a biltong or something. But God didn't, because he knew that this sucker is as bad as he is, so that he can withstand the persecution that a normal Christian would get when they are trying to send the message across the world. Remember, guys, if Paul was a nice person, a Christian man, and he started off like that, going into the Gentiles to preach the gospel of the Lord, he would not survive the conditions he would be subjected to. So God needed his conscience to be so broken that he would look at himself and say, I'm not worthy of anything, so I'm going to take whatever comes my way. God knew that in his badness, he was building strength for a later, greater mission. That's why a child would be defended by their parents, even when they are bad, because they know, if he knows the bad side of things, if he ever changes, there's no way he's going to go back to being bad, provided the environment is conducive. Live today that it's so bad that even when people change and become good, they quickly turn back and become bad. But anyway, just trying to drive you guys into the knowledge that, look, it's easy to judge when you are not involved. You have nothing to lose. But it's another thing when you have something invested in that very same judgment and you stand to lose. You would rather the judgment is different, knowing very well that it is deserved or is deserved. You know that it is appropriate, but you would rather it doesn't happen. So I don't know what I was trying to say now, folks, but yeah. Oh, it was all about the ANC. Now I'm saying to you guys, I became a doctor because of the ANC being in government. If it wasn't, I doubt I would have become a doctor. I can tell you that for free. And as a result, I am giving back by giving you free advanced lessons in mathematics for high school level. And there's free videos for you guys to view for mahala. I am surprised I don't see you guys subscribe in numbers, although I see views and you can see even the likes. Stingy guys. But anyway, I've noted though, people actually do like these videos, but it's the algorithm that actually prevents it, because I have at some point liked certain videos by other content creators, but you would see that that like does not translate to a like. Now, I don't know whether they decided to hide those likes, because there's a button you can press when you're uploading the video so that the likes don't reflect. I don't know if it is like that, or the very YouTube thing decides to make those likes as low as possible deliberately so that good content doesn't get to the people who need it very much. But you can see all the bad content that is out there on YouTube and all these other social networks. Everything that is bad, guys, trends. It gets likes. You'll find that this is a bad display on a video of some sort by a content creator, but you'll find having 10,000 likes in just a day or two. Do something good, it will have just one like for the next 2 years. Anywho, guys, I was just trying to breathe a bit. Let's just get to business. So I showed you guys in the class. So those who don't attend my classes, well, whatever, guys, you will lose. Anyway, let me tell you why I know this. The common ratio here is going to be a third. Why do I know it's going to be a third? Because it's the same general formula. So it doesn't matter where I start, because m can be any value rather than the first term like this one here. It can be any other term, but all I know is that the common ratio between any of the terms that exist is always going to be the same. So that's the idea. Okay, so by the way, we know, guys, that the sum to infinity here is given as 21 over 2. How do I know it's the sum to infinity? Because the top is infinite. Now, sum to infinity is a. Now, what is going to be a is when we substitute m over there. So we know that this is going to be 7 times 3 squared to the minus m. Not 3 squared, but 3 to the 2 minus m. That's our a value, divided by 1 minus r, which is a third. This must be 21 over 2. Then we sort this out. So when we sort this out, what happens? Now this is going to be 63, right? Because when we split, this is going to be 3 squared times 3 to the minus m. Now basically this is going to be 63 times 3 to the minus m over, now this is 3 times 1, that's 3, minus 1, that's 2, so this is 2 over 3. Equals 21 over 2. Right? Right. Now this is as good as flipping this about. So 63 times 3, let's see, what is it? 63 times 3 is 189. Okay, it's not gonna divide that. So this is as good as 189 times 3 to the minus m over 2. Okay guys, be patient sometimes with these. They will hurt you big time if you're not. So we cross multiply. So remember guys, we do everything the way we know. Or if we like, some students may just decide to say 189 over 2, divide by 8 throughout. Perhaps let's just do that. Cross multiplication will waste our time. So we know that we want to divide by that, so we get 3 to the minus m equals, so we get 21 divided by 2, that also divided by 189 over 2. Nice and easy, so we get 1 over 9. Okay, so we go on, so this is 3 to the minus m equals 3 to the minus 2. Do you see that? Because this would have been 1 over 3 squared. So when we convert this into negative exponents, then once we've got the same base, now minus m is equal to minus 2. So therefore, we can see that we are solving for m, not minus m. So m should be 2. Nice and easy. So can you see, this is not starting from the first term as this one would. This one is starting from the second term, but the common ratio would be the same. Okay guys, so that was a nice one. These are the kinds of questions we should be asking grade 12s. Right, so what do we get here guys? We know that this is good. Knowing the common ratio is going to be like that, yes, is perfect. This display over here, good, the final answer. So 4 marks. Now, you may ask me a question and say, what the hell, my friend? Or the A value, knowing that A is going to be like that. So yeah, 5 marks is justified. Before I said gibberish. Before I said some sort of gibberish. Okay guys, so I'm tired now. I'm gonna take a break, but you won't even notice I did. But those of you who pay attention, let me show you. If you pay attention to this, you see the time now is 02:20. You will see that when I carry on, it's gonna be some other time to show that I rested. Yes, I want you to know that sometimes when I finish these things quickly, but you will see that I took breaks in between. I do not have the stamina anymore. Okay, I'll see you in the next bit. You won't even notice I went away. All right, guys, so let's get to this question 4. Great, so we are told that the sketch below is for the graph of h, which is equal to 3 to the x minus 9. And when we look, the coefficient of that power, 3 to the exponent x, is positive, whereas the base itself is greater than 1. So we know that we expect a graph that appears above the horizontal asymptote, and it's an increasing function. Of course, minus 9 gives us the asymptote, which is the only asymptote in an exponential equation or function, which is going to be that constant. So we know that the asymptote here is at -9. Right, so then we're told that this is for x an element of -3 and 2. So this tells us that that value over there so we know that we're looking at -3 over there. Right, but now looking at this expression, we know that the x-intercept is at 2. Now to say that domain ends at 2 is incorrect, because that value cannot possibly be 2. That one. It's not possible. So we don't know what that value is. So this means this domain is not for this function entirely. It's incorrect. So something is not right. All right, because we know that when we say x-intercept, this is 0, we transpose the -9 into +9. That's 3 squared. Now x is going to be 2. So now this defeats the purpose. This domain is not for this function. Anyway, what would be the y-intercept? If we look, we make x 0, this is 1. 1 minus 9 is -8. Okay, that's what we've got. So please, folks, always work on the graph. Don't rush into the questions. You will see how easy it is to answer once we know everything. Write down the equation of the asymptote of h. Can you see? We already know that y is going to be equal to -9. Easy. 4.2, determine the coordinates of A. Now A is the y-intercept, so we know that A is such that h of 0 is 3 to the 0 minus 9, which we can say therefore h of 0 is -8. Can say therefore A is the point 0 and -8. Now, why do I know I could do this? This is the y-intercept. Okay, please make sure that whatever action you perform, you understand why. Substituting 0 and writing it in the ordered pair format, because we wanted the coordinates of A. That means both x and y. Right, 4.3 says determine the equation of a straight line G passing through A and B. Okay, so of course we need to first sort out the coordinates of B. You can say B is such that we've got 0 is equal to 3 to the x minus 9. Why do we know this? This is an x-intercept. So this implies that 9 is equal to 3 to the x, which also implies that 3 squared is equal to 3 to the x. Therefore, x is 2. You can say, therefore, B is the point 2 and 0. So this is another way of asking for the coordinates of B. Okay, we can say here also, we know that the gradient between AB is going to be y at B minus y at A, all divided by x at B minus x at A. Now, what is y at B? That's 0. Minus into -8 divided by x at B. This is 2 minus 0. So this is 4. Right, we can say then G of x must be equal to 4x minus 8, because that A is already the y-intercept, because the straight line that's passing through there is doing that. Okay, so this is G. So we can already see there that that point and that point are on it, so we don't need to find the y-intercept. So this is good, finding the gradient and writing the equation. Easy stuff. Okay, can you see, guys, once we work on the graph, nothing stalls us. Write down the equation of m of x plus 9. So this means we are killing this 9 over there. So we can already see that m of x is just going to be 3 to the exponent x. Remember, this is just an answer only question. 4.5. Now we need to write down the equation of the inverse. You should be expecting it by now. So we know that y is going to be the log of x to the base 3. So the base will always be 3. The number becomes what is the exponent. So if you don't know how this is done, check the videos in the channel. So 4.6 says, write down the range of m. Now you can see that this graph was supposed to be here. Now it starts off being here. Maybe let's just do something else. Okay, it's gonna mess with me. So this graph is going to come down here. And maybe this time around, that domain that they gave us would make sense for this one. Ne. That domain we were given would make sense in this issue. So we can say this is this point right now. That's not included with that one that's included. I think this is the domain because this would make sense for this graph when it's shifted back to its original position. But it would not be the case if this is what we did, okay? So I hope we are clear on this. Right, so now remember the range of the original function, the domain of the original function becomes the range of the inverse, right? So we can just say here the range, can just say y is an element of -3 is to 2, which is not included. So what do I know here? I know that the domain of the original function becomes the range of the inverse function. Okay, so that's the note you guys probably need to realize. So that would be 2 marks. Nice and easy. Now 4.7 says C is the result of point A. C is the result of point A when reflected over this line. Now folks, when we reflect a graph about any horizontal line, we do 2 things. We are going to do a horizontal reflection plus a translation. Okay, horizontally as well. So we do two things. Once we don't reflect about the axes themselves, we reflect about any other horizontal line. We're going to do two things. We will reflect first horizontally and then translate that point some units. But here's the easiest thing to do. Since we already have our business right here, this is our line of reflection. Now, folks, what I often do, which makes life easy, I look at how far is this point from this line. Right up to there. And this means this distance that point A is from this line, it will be exactly the same distance on the other side. Okay, so this means this should be exactly the same distance on the other side. Let's see, that is the one probably over there. So this means our point C is going to be here, where C is going to be, now remember, this distance is 2 units. That should also be 2. So 2 plus 2 gives us 4. But we're on the same horizontal plane, so this is going to be still minus 8. So a horizontal reflection, if you understand it that way, you are good. So we can safely say C is the point 4 and minus 8. Because that's what we are doing. Can you see? We first horizontally reflected this point and then translated it forwards 4 units. Good. Now we want the area of triangle ABC. Now triangle ABC is this one. Now we can already see this becomes the base, and then this one becomes the perpendicular height. Right? Right. So we know that therefore area of triangle ABC is going to be equal to half the base times the perpendicular height. This is half. The base is going to be the x at C minus the x at A, which is 0, into the height, which is the vertical line over there, is going to be the y at B, which is 0, minus the y at A or C, if you choose. It's going to be minus 8, which is going to be plus 8. Now what is that? Half of 4 is 2. 2 times 8 is 16. So that's 16 square units. It's done, folks. Right, so first of all, we get a mark for this point. Then this calculation and that calculation, that's 3 marks, and the final answer in the correct format. Okay, guys, so this is essentially how we handle functions. As you can see, a bit of geometry can be brought. Don't say this is not paper 2. Okay, let's do the next question. So we've got question 5. Question 5 says we've got f, that is minus 2 over x plus p plus q. So we're told that the equations of the axis of symmetry are these. So this is the positive gradient and the negative gradient. Okay, right, but anyway, what we know is that if this is the asymptote and that is the asymptote, Do you see, guys? You need to apply your knowledge. Asymptotes, these are the ones, they are orthogonal. What do we mean by orthogonal? We mean they are at right angles with each other, but in the perfect horizontal vertical axis or xy axis. That's orthogonal. But if it is the issue where they are perpendicular but not on the perfect horizontal and vertical axis, we just say they are perpendicular to each other. But when they are perpendicular to each other such that we are looking at the plane on the xy axis, we can say technically that's orthogonal relationship. Okay, so that's why sometimes we call this hyperbola a rectangular hyperbola. The reason for it is because the asymptotes are orthogonal. All right, so as you would know, rect means erect, so to speak. Rect, right, recht, right. So that's the right angle, but on the perfect vertical plane and a perfect horizontal plane. So we say that is orthogonal. Okay, just remember that. So if somebody asks one day, why do we call this a rectangular hyperbola? It's because the asymptotes are orthogonal, or they are perpendicular to each other on an xy axis plane. I hope that is clear. But now, what was I trying to do? I know that also the axis of symmetry, they pass through the point of intersection of the asymptotes such that they themselves are perpendicular to each other. Yes, 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 yes. So this would be the one axis of symmetry, that would be the other axis of symmetry. I hope we are clear. So this means, guys, the point of intersection of these two is the center of the graph. Okay, now what do we know about the center? The center is also the point of intersection of the asymptotes. So that's the center. So this means if we find the coordinates of the center, we've literally found our asymptotes. Okay, so it helps to understand the construct of each function and understand the very unique characteristics of those functions, because any given piece of information may lead to a solution if at all the question is meant to be tricky. Now let's do it. 5.1 says let's find the values of P and Q. Can you see? We know that the center is such that minus x plus 8 is equal to x plus 2. Why? This is the point of intersection. Let's just say boy. Boy. This is the point of intersection of the axis of symmetry. Right? Please know the reasons behind. You don't necessarily have to write them, but I think it is best if you do, because it portrays that you are doing this from an understanding standpoint. As I said to you guys, there will be a time when your school is under investigation and you are probably one of those students, and you don't want that situation to find you, especially during the finals. And I've been preaching this, and guess what? It happened last year. And certainly those students have had their marks withheld. And that means if any one of them is not responsible or not even the culprit, but because, you see, you don't clarify how you write your answers to separate yourself from the rest, you end up being part of the investigation, and that means you lose your spot at university, because those who will submit their marks and qualify, they will take your spot, and by the time you have your results, you'll be staring at them and not getting anything. So take nothing for granted. That's just the message. Transpose this, is going to be minus 2x equals, we transpose that, we get minus 6. Therefore, x is equal to 3. Therefore, y is equal to, we substitute 3 into any one of those two. If we put 3 there, it's going to be 5. Okay, nice and easy. We can say, therefore, the center is 3:5. Right? Remember, the center, in principle, it's minus p is to q. So this means this dude is going with that. And this one goes with that. But just remember, if we want p, we are going to multiply this by negative as well as that value. So we can now write that, therefore, p is going to be minus 3. We take the opposite sign. And q is 5, as it is. I hope you guys are clear. Of course, this is notes. It's not something you need to write. This is just a reminder. You don't write that. Okay. Nice and easy. So can you see, guys, if you understand what you are doing, you will always win. And the center is always minus p is to q. Of course, when the equation is given like that, but technically, you may still represent it as p is to q. I always hate negatives, so I prefer this format. F of x is equal to a over x minus p plus q, so that that center becomes nicely positive. Okay, but anyway, it doesn't really matter. It still caters for anything, no matter how you write that formula. Okay, how do we get our marks? For the method, yes, for those 2 points. So we get our 3 marks and we move on. 5.2 says, if p is minus 3, can you see it's confirming our solutions? Now determine the coordinates of the x and y intercepts. I feel like that question should not be asked. Maybe this one for 6 marks, you know. I don't think that question is necessary. These are some of the things you just realize. Come on, guys, this is grade 12. This is not grade 10 or grade 11. This is grade 12, and they already know a hyperbola. Can't be asking those things. They need to know when to do those things. Just say, sketch the damn graph. Let them sweat. Anyway, f of x is now minus 2 over x minus 3 plus 5. So that's the full equation. Now we can say for x intercepts, it is such that 0 is going to be minus 2 over x minus 3 plus 5. Transpose 5 becomes negative 5 over 1 equals minus 2 over x minus 3. We know the gymnastic of choice when we have situations like this. Minus 5 times minus x is going to be minus 5x plus 15 equals minus 2. This means minus 5x equals, transpose this, it's going to be minus 17. Therefore, x is 17 over 5. You can say, therefore, the x-intercept is going to be 17 over 5. 17 divided by 5 is to 0. Remember the question said coordinates. It did not say coordinate. Can say for y-intercept, it is such that we've got f of 0. Can even say y is equal to minus 2 over 0 minus 3 plus 5. Therefore, y is, this is 3 by 5, that's 15, plus 2, that's 17 over 3. Therefore, the y-intercept, remember this is a point, is 0 and 17 over 3. Okay, we're done, guys. We've done it nice and easy. Please try to underline your subtopics to suggest that you're doing this and doing that. When you finish, you lock it. Okay, guys, so how many marks are we getting? So we get a mark for those points. And of course, for knowing that we need to substitute the zeros, I suppose. Sometimes these questions are crazy. For putting those zeros, I suppose, we get an extra mark. That's the only logical explanation I can give for that mark. So let's do the last question. The last question says 5.3, sketch the graph showing all the intercepts with the axes as well as the asymptotes. Okay, we are good. Right, now we know that our vertical asymptote is at 3. So if I say my 3 is over here, no one is going to tell me anything. And then the horizontal asymptote is at 5. I can decide this is my 5. No one is going to tell me anything. Remember, this is a sketch. It doesn't have to be to scale, guys. A sketch does not have to be to scale. Wherever you decided the value is, as long as the graph is going to be representative, that's what matters. As long as the graph will represent the equation given. So we know that we are deciding this is 5, this is 3. Okay, now what is this x-intercept? It's 17 over 5. So what is 17 over 5? This is 3,4. So this is good because it's beyond this point. 3,4, we can put it over here. And then let's see 17 over 3. It's 5,7. So 5,7, we can place it here if we like. So the graph looks something like this. It will approach the asymptotes but never cross them. And then this one is going to do the things. Okay. So now what is that? This is 17 over 5 over here. Then that is 17 over 3 over there. Then we label the graph that this is F. Okay, guys, this is done. You label the axis, you show those points, and we show everything. So guess what? We get a mark for the shape, provided it's correct. How do I know this is going to be like this? When A is less than 0, this A value is that constant at the top. When this is less than 0, it means our hyperbola is in the second quadrant and fourth quadrant. So this is exactly what I know. So we get a mark for the shape. Secondly, we get a mark for any of the intercepts. But remember, both x and y intercepts have to be correct to get that mark. And then we get the third mark for the asymptotes. Again, they must both be correct. Otherwise, that mark gets lost. Okay, guys? So that one was easy for some 10 quick marks. Now, guys, is the time for me to add some extra questions. We're almost done, don't worry. I will not add any more questions after this. Now, say, guys, there is something I want to say, but I wonder if it is necessary to say it. Okay, I just need to say something. Let me not add a question to avoid trouble. This graph, guys, if you look at this portion of the graph, if you look at that portion of the graph, it is a reflection of this graph. It's a mirror image of that other graph about that axis of symmetry with the positive gradient. If I was just to draw it, you see the axis of symmetry would pass over there. Let's see, what would it look like? This would be y is equal to x minus 3 plus 5. So y is going to be equal to x plus 2. Right, so if it is x plus 2, I know it's going to be minus 2 and 2. So let's say this 2 is over here. Right. So if you look at it, the other axis of symmetry would be cutting over here. Of course, forgive my graph, it's supposed to be perpendicular, but it didn't come out perpendicular anyway. But yeah, that would be the other axis of symmetry. It should be exactly perpendicular to the other one. Let's just say that's the case, and then of course that's our center. Now also the axis of symmetry, will show them with a dashed line. Okay, so that's good. So now what I wanted you to know, guys, that this particular situation over here, okay, this graph is a mirror image of that graph about this line, which is that axis of symmetry. So say for you guys, I give you a point in here and say this point, let's see what value do I want to put there. Let's see what happens to my equation when I put I will not say what I put, but I'm just gonna give you the point. So I'm also giving you a chance, guys, to get into the examiner's mind, okay? I'm giving you a chance to get into the examiner's mind. Okay, say for example, we've got a point. If I tell you, this is your extra question. If I say if point, okay, let's not say point, let's just say if a with 2 is to 7 lies on the graph of f. Instruction is write down a prime, the mirror image of a when reflected about y is equal to x plus 2. Now, these are some of the questions that are going to give you a headache if you don't realize. Now, I need you to notice something. Let me write this equation properly. Okay. Now, you would be seated there and wondering, hey, well, what is that? And of course, point A is over there. It's a point in that part of the graph. Okay. Right. Now, if I want the mirror image of A about that line, what you need to notice is that this line is the axis of symmetry with the positive gradient. And obviously, the axis of symmetry here is the line of reflection, which we call the inverse. Right? So what should be this point? The answer here is that this A prime would be, we just swap those coordinates. Easy peasy, lemon squeezy. Right, because obviously the knowledge that is given here, it should be such that that point, when drawn perpendicular to that axis of symmetry, it should essentially, I wonder if I'm saying the right things though. You know, sometimes it's easy to say things that don't make sense, but all I can say, guys, that point would have a mirror image over there, like that. Ne? But bear in mind that that point must be perpendicular to the axis of symmetry. As you can see, I didn't draw them accurately. So it's going to look like it's skewed, but this angle here must be 90 degrees. Just think about it that way. Now the mirror image is going to be A prime. Can you see it makes sense? Because this point is ahead of 3,4. It should be 7. That makes sense. But if you look at it, it's below 5. And perhaps, you know, at the level of, you know, the y-intercept of the axis of symmetry. So that should be 2. So can you see, those are inverses. Sometimes you will be given this indirectly, as you can see, without being given the axis of symmetry. And then a question like this gets popped and then you don't know what to do. So understand your hyperbola very well. At some point, I think it should be the case. I may even ask, what would be the gradient of my hyperbola at that point, where I can choose that x perhaps is, if I decide x is minus 2, I can ask you what would be the gradient at that point. This is when you guys are now doing calculus, which is coming in term 2. But I know my audience has students who are going to be writing the May-June exams. So let's imagine in the May-June exams, you get given a question like this. Remember, guys, anything can be asked. Do not say, no, I've never seen it. Everything gets asked. So what are you going to do? Are you going to cry? Are you going to cry? Let's call this point Q, not Q, but let's call it point M. Now that's the second question, guys. That's the second question. Determine the gradient of f at point M where x is equal to minus 2. Remember, this is a revision session, so don't be crying on me here. Say, hey, time is what? Time is money, guys. But not today, only tomorrow, okay? So how would we go about this? Now, I know you don't know derivatives, but now this is for those who are doing grade 12 for May, June exams, okay? Because they already know differential calculus. Some of you may not know this. So this question, I can put asterisks on it so that if you are a new 2026 matriculant, you don't need to worry about this question. But look at it as soon as you study differential calculus. But my suggestion would be just watch on and learn, because we'll have something up your sleeve, okay? Now, I've got a shorthand technique of finding the gradient function. And I'm just going to surprise you and give it to you. So I know, guys, that f prime of x is going to be what? Yes, it's going to be 2 over x minus 3 squared. How do I know this? Ke itse bjang. Oh, Hannah, bjang. How do I know this is going to be my gradient? So what was the question? Determine the gradient. So the gradient is f prime. So we can easily say now this implies that f prime at x is equal to minus 2 will give us the gradient. So this is going to be 2 over minus 2 minus 3 squared. Therefore, f prime of minus 2 is equal to. Now let's do it. So this is 2. And mind you, this is positive now instead of negative. I hope you can see it. If you don't see it, it is going to see you. You get it? Yes. So this is going to be 2 over 25. I mean, you can see that graph is almost flat. So this is very close to 0. It's almost a horizontal line. So can you see this thing doesn't lie. This thing doesn't lie. Now, some of you would be wondering, where the heck did I get that first derivative? How did I know it's going to look like that? Well, folks, here's a shorthand technique on doing this, which may work most of the times, but not all of the time. So if you've got f of x is minus 2 over x minus 3 plus 5, we can still go on and say f of x is minus 2 into x minus 3 to the exponent exponent minus 1 plus 5. Of course, this is dangerous. Now, you just use the power rule somewhat. So minus 1 times minus 2 is going to be 2 into x minus 3. Now you subtract 1. Becomes minus 2 plus 5. Okay? This is the first derivative already. Right, now when we rewrite this whole thing, by the way, the first derivative is going to be like that. The first derivative of a constant is 0, so it's not there anymore. So I can say, therefore, f prime x is 2. Remember, we hate negative exponents. We hate them with a passion, so that's how I got it, guys. Now, the question is, will it always work like this? Well, I don't know. Okay? But that's something I always thought about, played with, and it came out alive. Now, folks, you're not told the rules of differentiation very well, I noticed. But hey, it doesn't matter. Let me show you anyway. Okay, guys, that was a bit of a glitch. I don't know, this thing blinked. Now, let me show you the proper way of doing the derivative for a hyperbola, especially when it is not the simplest version of it. Now, you're not going to do this from first principles, of course, but I'm going to show you something that you're not aware of. Now, folks, when we have our f prime x is equal to minus 2 over x minus 3 plus 5. Now, we write our hyperbola first as a minus b over upper x minus p, or whatever you call it. So we need to write our hyperbola like this, as a ratio of binomials. Because when it is not, then it's not easy to apply the rules of differentiation. Now, you guys don't get taught this, which is sad, We knew these things, but we were never really asked a question around these. Let me show you now. How are we going to do this, folks? Well, this is over 1, isn't it? Yes, of course. So we know that our f of x is. So now when we want to write it in that manner, we know that this is over 1. So what are we going to do? We have our LCM as x minus 3. Because we just say 1 times x minus 3, it is that. Now x minus 3 divided by itself is 1. 1 times the numerator is just minus 2. Plus 5. Now this is going to be 5 into x minus 3. Okay? Continue. F of x is equal to minus 2 plus 5x minus 15 all over x minus 3. And therefore, f of x is going to be 5x minus, I should have said x minus b, not what you call, not a. It's not a there. That's the 1. Minus or plus b, however you want to see that. Now this is minus 15 minus 2 is going to be minus 17. All divided by x minus 3. Nice and easy. Nice and easy. So from here, we know that the rules of differentiation says if we've got what we call the quotient rule. Remember, you are so used to the power rule. There's what we call the quotient rule. Actually, there was a video I made last year, just before the finals, on differential calculus, and I showed these rules, but anyway, let's not talk about it. That video, I found some defects in it, and I deleted it, okay? So the quotient rule says here, we are going to have, right, it says f prime x is going to be f. Okay, wait, this thing, you consider this, by the way, let me just show you. When we've got a function like that, this would mean we can say f of x is going to be equal to, remember this is a function by itself, it's a linear function. We can call it h of x divided by, this one is also a function by itself, we can say g of x. So now what does the quotient rule says? It says the first derivative of our f, of course, hoping that we are doing that, is going to be equal to, is going to be h prime x times g of x minus g prime x times f of x. Dilibele kodwa sizoyibona. If the answer iphume right, then I did it correctly. Konje, what do we do at the denominator? Hey wena sonqhela. Hey bafethu, thengathi lahlekile, but anyway, if ndiyibhudile ne, nizobona ngantoni? Sizobona ngezinkinga. Is it correct, guys? Hey. Tension no f of x. I can't have f of x. This should be g prime times h of x. Ne? I think so. First of all, it's going to be the derivative of the numerator multiplied by the function on the denominator. Subtract the derivative of the denominator multiplied by the function of the numerator. And then we divide this by g of x squared. Ne? I think that's what the quotient rule says. But hey guys, sometimes I forget. But if ndiyilibele ngokupheleleyo sizobona ngale answer ukuthi ngaphumi. I know this answer is correct. Okay, if I pull me this one, come on, man. Ay. The tablet seyangiqhela seyicinga uyandazi. I don't know if ndibhale kahle guys, but isn't it the product of the two though? Is it just one? Is it not the product of the two? Is it not the product of the two? Oh. Ebana, ke tlo ira bjana. Eish, ndilibele guys le rule, yes. How can I forget something like that? I think it's like this, guys. But why umnqwazi ungaqini? Utheni umnqwazi ungaqini, guys? Ay, yabona ke. Awuthi siqhubeke in case. You know, I don't have my phone next to me now. I would check it quickly. But let's just put this to use now. Say, okay, fine. This implies that the first derivative is going to be... Now we take the derivative of the numerator. We know that the derivative is going to be 5 here. The constant falls away. So this is just going to be 5 into what was g of x? That was x minus 3. Then minus the derivative of the denominator is just going to be 1 into the function of the numerator. So this is 5x minus 17 all divided by x minus 3 squared. Let's see what happens. This is 5x minus 15 minus 5x plus 17. All divided by x minus 3 squared. Look at that. What do you see, guys? So 17 minus 15, that's 2 over x minus 3 squared. Iyo bafana. We are done. It is the one. So you can see, guys, this is the first derivative. If you are asked to do it, the quotient rule is your friend. But first, you write the hyperbola in this format. Sometimes you are given this hyperbola in that format and then be told to ask it in the standard format. I was just teaching you a thing or two here, so please guys, don't take these things for granted. You do this at your parish. So I knew it guys, I knew it. That's the one. Now this means we may even ask you a further question and say, calculate for us the equation of the tangent to the graph of f. at that particular point. Now you know how to find the gradient at that point. Then you can use f of x. Since we thought about it, let's just say now here's an extra equation, an extra question. I just am going to indulge, guys, because you know what, you have to learn. I cannot just waste your time by showing you solutions, but you don't get an opportunity to learn. It says now find the equation of the gradient, of the tangent to f at point M. Nice and easy. So look, we just did the gradient. This was just learning. We were learning here how to do it, okay? Although I kind of forgot it, but yeah, this is the one. Now what are we gonna do? We will take the gradient. Oh, by the way, first of all, we want point M's full coordinates. So we know that M is such that we've got f of -2, which is gonna be -2 divided by -2 minus 3 plus 5. Therefore, f of -2 equals, I don't want to suffer now. This is -2 over -2 minus 3 plus 5. So this gives us a 27 over 5. So we can say therefore point M is -2 is to 27 over 5. Okay, what is that? So this is 5,4. So looking at the scale drawing that we did, it's above 5. So yeah, that could be 5,4. Makes sense. Now we know that we just need the equation. We can say then we know that y is equal to mx plus c. Now the gradient, we saw that this is 2 over 25, right? As we did above. This is x. X plus c. So we know that point M has -2 is to 27 over 5. So this means 27 over 5 is going to be 2 over 25 into -2 plus c. Let's finish it off on this side. Can say that means c is, so let's see, we've got 27 divided by 5. And then this one is going to be positive. So it's going to be plus 4 over 25. So this gives us a 139 over 25. Can say therefore y is equal to 2 over 25 x plus 139 over 25. Okay, that is not too big because it's just 5,56. So this means this is just 5,6 essentially. So if we look at this graph, that would be the graph of the tangent there. Yeah, can you see? That would be the tangent at that particular point. Right. So as you can see, everything is working out because the y-intercept is actually 5,56. So that's good. And it's just 5,7. So almost like that y-intercept. 5,6. Yeah. That was 5,7, so this is 5,6 or so. Not too bad. So as you can see, guys, this is how you would go about the business. Now, I would tell you to take note of these things that I've just shown you, because you never know when they're going to haunt you. My students, last year when we were preparing for the finals, we just imagined a question about a tangent to a cubic function. And we imagined the range to which this can happen. And I can tell you that question 6 was testament to my imagination. Exactly what we thought came out. And they were all smiling because they nailed it. Anyway, guys, so don't take anything for granted. Trust me, this may look like an overkill, but this is a learning experience. I think at this stage, I would like to show you one last thing before we close down the learning here. Sometimes I know that the inverse of a hyperbola, I don't know if your exam guidelines say you don't have to worry about it, but let's just imagine in the May June exams you get surprised. Now here's the last question. Okay, let's not say find, but rather determine the equation of the inverse of f. Okay. Now these are very important questions, guys, that you need to look at. When you practice, you solve the questions that are there, you start imagining things after that. Believe me, nothing beats that kind of strategy, because you will be so comfortable with the subject. Whenever a challenging question comes, you're just going to chew upon it like it's popcorns, because your brain is already highly functioning. Anyway, let's talk about the inverse. We know that, of course, the inverse of f is going to be such that we swap x is going to be equal to minus 2 over y minus 3 plus 5. Right. I'm going to show you this long method, but essentially there is a shorthand technique which I'm going to highlight at the end. So this implies, what are we going to do? What are we going to do? We want to solve for y. So we can move this 5 to the other side. So this is going to be x minus 5 all over 1 equal to minus 2 over y minus 3. Now look what's going to happen. We cross multiply and do our shenanigans. So this implies that we're going to have y minus 3 into x minus 5 equals to minus 2. Then we divide by the x term, and I get y minus 3 is equal to minus 2 all over x minus 5. Therefore, y is equal to minus 2 over x minus 5 plus 3. So that's how we get the inverse of a hyperbola. Okay, we do the same thing that we do. But now look at the shorthand technique. Do you see that we literally took this 5 and replaced 3? And we took this 3 and we replaced the 5. That's all. You keep the signs as they are, where they were, like this plus must remain, that minus must remain. We just swap the actual whole numbers or values or constants. Leave the signs as they are. Can you see? That's exactly what we did. So when someone asks, write the equation of the inverse, especially when this is not the question. Maybe somebody says, write down the equation of the inverse. You just swap that 5 for 3 or whatever was p. Then you take whatever was p, it becomes q. So essentially here it's like swapping p and q, but leaving the signs behind, because the function doesn't really change its character that much. because as I told you that would become a reflection about that particular line. So the inverse in terms of a function looks slightly different, but it will actually be the same graph on the other end, because this accommodates for those translations that took place. Anyhow, that would close down the extramural activity for a hyperbola. Of course, guys, I'm going to take you through some of these functions individually. I know I did one video on functions and I left you with just what a function is, because we have to define it and we have to understand what it is and what it is not. By the way, guys, something came to my mind as I was seated and drinking my coffee here. You know that question we created above? I have a beef with it. Now, let's say if someone decided that if someone says, what is the first, where was the question that we made, by the way? This says, which term of the sequence in 2.2 will be the first to be greater? Can you see term 1, literally, guys, term 1, do you realize term 1 is 661? This is the first term that is greater than, 63. So you can even present that answer. As you can see, it already tells you and I that I didn't carefully think about this question. And this is what I see most of the time with these provincial papers. So some student may actually choose to write term 1. Okay? Because term 1 is the first of all these terms. And if you look at that term 13, that term 13 is the last term, rather than the first, is the last term. Okay, let's not complicate it, guys. Remember, in maths we can read however we choose, but now I'm starting to feel a bit under pressure that question was not carefully thought out. Okay, so we may have to refine it in the near future. Of course, when I give you some more examples, I'm gonna try and refine it properly. There are ways to create a question that can be answered properly. This one, I think 13 would be good, but certainly not term number 25. But if you say term 1, I would also accept that answer, because this question does not negate that term 1. And in actual fact, term 1 is the first, to be honest. But anyway, it is what it is. Because we read from left to right, so it's actually term 1. And as you can see, we went through all the trouble for just term 1. But then I actually wanted to showcase how inequalities can work here. But I guess the design was not the perfect one. So that's just the flaw I noticed as I was thinking about it. So as you can see, guys, you think about these things, then you start to know when something is wrong and right. As you often hear me making noise, sometimes complaining, this is wrong. I guess this imperfection I've just shown you now, also gives you a bit of a diagnostic report on how these provinces get these questions wrong. It's because they set these questions in the last minutes and send them through to the quality assurer, who's also not going to look at it. It's just going to wait until the last minute, tick some boxes. They didn't know that there was a problem. Then when later this thing is out, there's complaints when the markers get busy. It only gets revealed then, which is too late. So if people can just do their job, as you can see, I created a question out of comfort, but then it turns out it's not as perfect as I wished. And remember, when you create a question, for exam purposes, it must not allow any form of controversy or present any ideas about ambiguity, or at least being vague. The question has to be precise so that nobody misses it because of misconceptions or whatever. So you can already see that if you want to create questions, you create them on time, you ponder upon them, sometimes you sleep on them so that you wake up the next day and see if you're still convinced that the question is perfect, it's bulletproof, it doesn't have holes in it. Then when you are sure, you submit it. Even then, you should be submitting on time so that the quality assurer also looks at that question, attempts that question, looks at the time frame it took for them to figure out that question so that they can decide if they're going to include it in the exams or they will send it back to the creator to recreate it better to suit a particular time frame that it should be for, and the marks as well. So guys, setting exams is not an easy thing. You don't just thumb suck them. As you can see here, the proof is before you. And it, in some ways, explains the issues that we see in these exams. Okay, guys, I think I'm getting too comfortable. So we're told here 6.1 sine 32 degrees is equal to P. But always write it as a ratio because we say these are trigonometric ratios. Okay, guys, we know that we will not be using a calculator here. So our diagram is as necessary as a calculator. Okay. So we know that 32 is an acute angle in the first quadrant. So if this is 32, this must be 58 degrees. Okay, calculate everything because you may be asked about it. Sine is opposite over hypotenuse. Therefore, we solve x squared plus y squared equals r squared. From Pythagoras, now x is on the positive axis, so we will take the positive square root of 1 minus p squared. Please, you must not wait until you answer a question that requires this. You do it immediately. Then let's do 6.1.1 says we need sine of 212. Now sine of 212 is unfortunately a big angle. So this is 180 degrees plus 32. So sine is negative. We take the acute angle, so this is going to be minus p. See, this question doesn't require the terminal arm diagram. So this is what we get, the reduction. This is 2 marks. But remember, guys, if I don't see this, you just jump from here to here, you will be penalized because it suggests that, look, you have to kill the impression that you have used a calculator. Although you can still use a calculator to cheat in this manner, but the way you write it, it shows that you respected the rule. But if you just jump around, I don't know if you are doing the right thing or not. So avoid unnecessary problems, guys. You lose marks out of all of this nonsense you do of being complacent. Here, we don't care about your sob stories. We have our own sob stories to tell. So yours don't matter. Even if you can tell me that you just lost a relative or something, that's why you couldn't write well, I don't care. This is academics. This is not some social event or whatever. You gotta shape up, or you just report sick and take the exam at another stage when you are ready. But if you are taking the exam, you must take it, guys. Okay, 10 of a negative angle is minus 10, 32. This is going to be equal to minus 10 is opposite over adjacent. So that's it. Now remember, in grade 12, we don't need to rationalize this denominator. We just present the answer. We show the reduction. Usually that calculation comes in handy. That should be 3 marks, not 2. 6.1.3 says we need to sort out cos of minus 482 degrees. Now cos of a negative angle is a positive cos of 482 degrees. This is now 360 degrees plus 32 degrees, isn't it? Yes. So this is in the first quadrant in principle. So this is cos of 32 degrees. Cos is adjacent. That's root 1 minus p squared over hypotenuse, which is 1. But 1 is as good as not visible. So what do we do, guys? This reduction and the answer. We should get a mark over there. We should get a mark. I don't know why there's 3 marks. Maybe for knowing that this is going to be positive. It doesn't matter after all. Okay. Maybe I'm marking it in the wrong place. Maybe we can say the reduction, the ultimate, and the final answer. Okay, guys. Easy marks here. Remember, this one was easy. It just involved reduction formulae only. Okay? But let me ask my own question, because you know what? I can. 6.1.4. I can ask my own. You see. These things are interessant. I will ask my own. Now I want sine of 26 degrees. Yes, I can ask it. So how are you gonna do it? Yo, wafufulela ngwana motho. Una le tswekere kampa o etsahalang ka wena? Ka una le tswekere go shebile tjena. This is sine of what is 26? Yes, 58 minus 32. Do you see that 58 degrees? If you never always check it, it will trip you so bad. You are going to feel burning. Now we use our identities. So this is going to be sine 58 degrees, cos 32 degrees. Come on. Minus cos 58 degrees, sine 32 degrees. Expansion using identities. Now what is sine 58? Is opposite of a hypotenuse. So this is going to be the square root of 1 minus p squared into cos 32, same thing. Washamkuku, washabalala. Cos 58, kiman, ki p. Sine 32, ki p lien. Hewan. Khantu hirala mona. We are the magics. Now that square root multiplied by that square root. Guess what happens? Guys? You. If I land by square root 3 multiplied by square root 3. Banlo with 3. Yes. So this is going to be 1 minus p squared minus p squared. So this is 1 minus 2p squared. Getyiwe. Kiphetho kitu. Yeah, termino. Nka ke yona ntho eno. Nka wa utlwa jwale. O tlo hlanya. Substitutions. Ro qetile. Ere re o fe ye nngwe, bonus mark. 4 marks this one. Now I'm just trying to emphasize the one thing that, guys, when you do these questions, you will always get them in 3 formats. It's going to be perhaps a direct question, one that involves reduction formulae, one that involves identities, whether the compound identity or the square identity or the tan identity or the double angle identities, but any one of the identities can be there. That question is never complete without some form of identities. Okay, let's not waste time. We get to 6.2. 6.2, we need to prove the identity. Nice and easy. Left hand side is complicated, isn't it? Yeah, this is cos squared 90 degrees plus y times sine 180 degrees minus y minus sine 360 degrees minus y. And then times cos squared y. Cos wamuhlala nje elambile. Anyway, divided by cos 360 degrees minus y. Okay, this is equal to, now the reduction, 90 plus third quadrant, sine must be negative, the cofunction, but now it is squared. Yes, this one is in the second quadrant, sine is positive. Minus into sine of 360 minus is going to be minus sine y times cos squared y, all divided by cos y. Okay, now remember guys, you get marks for these reductions, all of them. These are just easy marks. Now let's sort it out. We get sine squared y times sine y minus, in fact it changes to plus, sine y cos squared y. Okay, sometimes don't rush, don't say sine cubed y, but even if you did, it's okay. It will always correct itself. So this is cos y. Now in the numerator, we can factorize by taking sine y. Then we remain with sine squared y plus cos squared y, all divided by cos y. Now sine squared plus cos squared y, that's a square identity. So that's just 1 divided by cos y. Now this is sine y divided by cos y, which is 10y. This is equal to the right hand side. Nice and easy. Now folks, what are we doing? We got 1, 2, 3, 4. We get 5. We get 6 for the identity. But that should be 7 marks because factorizations were key to this situation right here. Anyway, leave it alone. Maybe you don't get the answer because it's already there, but since we used an identity to get the 10, I think it is considered. Or maybe we can say, well, whatever. Now let's get to 6.3. 6.3 says, given that cos x is to sine x is to root 3 sine x are the first 3 terms of a geometric pattern. What did I say? Trigonometry is algebraic geometry, or you can say it's geometric algebra because this is nothing but algebra. But now can you see sequences and series are coming in? Right, determine the value of x if x is less than 90, greater than 0. Technically, I don't like this question. It's too simple. Okay, maybe it's not too simple, but I would rather we just jump to that one to create a higher grade question and destroy that little confidence you have. Right, we want x. Now look guys, a geometric sequence, common ratio. So this means sine x over cos x must be the same as root 3 sine x over sine x. Guess what? Oops. So this implies that 10x using our identities is root 3. Now root 3 for 10 special angles, this is 60 degrees. Done. Because 60 is less than 90 greater than 0. Very easy, guys. Of course, you get a mark for this. How do you know this is the common ratio for a geometric sequence? And the answer, this should be just 2 marks, or perhaps using the identity there. Yeah. Okay, that was 6.3.1. Oops, label correctly. Don't be too excited. Now, hence calculate the sum of the first 10 terms. Can you see? Well, we know that what is our common ratio? Is root 3, because that's the tangent. So we know that, well, root 3 is 1 comma some change, so r is greater than 1. S sub n is going to be a into r to the n minus 1, all divided by r minus 1. Remember, guys, don't rush. We were told clearly on the instructions that whatever we've used to determine our answers, we must show. So what's the first term here? The first term was cos x, right? But now what's cos x here? It's cos 60 degrees. Into the common ratio, we just don't need anything. It's just root 3. Or you can write 10 60. It's up to you. But this is just root 3 to the 10 minus 1. All divided by root 3 minus 1. Therefore, as 10, this is going to be cos 60, which is half. But anyway, just do it. Into root 3 squared to the exponent 10 minus 1, we close, divided by root 3 minus 1. The answer we get here is 165,29 to 2 decimal places according to the general instructions. Nice and dandy. See? Yes, don't cry and say, hey, sequences and series intrigue. They are here. Okay, what are you going to do about it? Nothing. Substitution answer. It ends by 4 marks. Okay, knowing that this is the common ratio 3, the first term is going to be cos of 60, I guess. Yeah, but it's weak. It should be just 3 marks maybe. Okay, let's do the last question quickly. We've got 6.4. We are now told to find the general solution here. So this is a quadratic equation. Didn't I tell you? Yes, if you watched that video I showed you guys, this is going to be easy. So we've got 6 sine x, sine squared x, minus 7 cos x, minus 5 is equal to 0. So we can see there's cos x. We can use our square identity. So this is 6 into 1 minus cos squared x minus 7 cos x minus 5 equal to 0. We fall 6 minus 6 cos squared x minus 7 cos x minus 5 equal to 0. We write this properly, minus 6 cos squared x minus 7 cos x. 6 minus 5 is going to be 1. Now, I can see 6 and 1 will not give me 7, right? Is it? Yeah, because this is negative, so there's going to be a cancellation instead of addition. If this was a positive 6, yes, it would work, but it's not going to work when it's a negative. But again, you can check the discriminant, but I already know that it's not going to work. So x, not x, but what? The variable here is this dude. So we know that cos x is going to be minus b plus or minus square root of b squared minus 4ac all divided by 2a. Remember, show everything, guys. Follow instructions. Don't disobey instructions. You will be dead. Alone And when you die, don't ask me any questions. How did I die, sir? Yes, you died. Let us see quickly. This is 7 plus the square root of minus 7 squared minus 4 into minus 6 into 1. 2 into minus 6. Okay, the first answer is minus 1,29. Minus 1,29. In fact, to 2 decimal places is going to be 30. Ne? Is this correct? No. We have to reject, because remember the maximum for cos x is equal to p. P must be less than or equal to 1, greater than or equal to minus 1. This is already beyond that range. So we reject it. So our cos x is re qetile jwale ehlile re badile bana beso le ska re ha re a bala. No, a ke le senyetsa nako mona. Empa ke ile ka le ruta ntho tse bohlokwa. Re etse 3 decimal places ka mona. Just for fun, all right? Okay, all right. So this one is acceptable because it's within the range. So we can say, therefore, maybe we're not concluding here. We can say, therefore, cos x is equal to 0,129. Therefore, x is going to be plus or minus arc cos 0,129 plus k times 360 degrees. Where k is an element of integers. Now, therefore, let's not get conclusions. Let's not rush. Therefore, x is going to be equal to, I can just say arc cos answer. You see, these calculators are perfect, man. So this is plus or minus 82,61 to 2 decimal places plus k times 360 degrees, where k is an element of integers. See, finished, done, and dusted. Okay, guys, I've shown you these for quite some time now. There's plenty of videos on these kinds of questions. I'm not even going to try to be creative. I gave you a crash course on this. You can watch it in the channel. I gave you some specific questions of challenging orders and formats. This should not be a difficulty at all. Otherwise, guys, how do we score the marks here? We're getting 7 marks. When we use an identity, we get the marks. Substituting into the quadratic formula, yes. Selecting this answer against the other, yes. The method, yes. The answer, there's 2 marks because there's 2 solutions. One is positive, one is negative. This means one is in the first quadrant, one is in the second quadrant. By the way, the negative version of our solution can also be looked at as 360 minus that 82. Some students like to use that technique. Where's this calculator? Some students prefer that technique. I don't know, my mouth is getting dry. So 360 minus 82,61. This could be expressed as just the negative solution there to it, in case you wabilayel. This is 277,39 degrees plus k times 360 degrees. Of course, for the same issues, if at all you decided to split those solutions, okay? So this is just a suggestion for those who may be wondering, but why are you having plus or minus 82? I mean, this is in the fourth quadrant, man. It's an acute angle in the fourth quadrant. Do not ask me the things, man. Don't ask me the things. Now, what are we doing here? 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 6, 7. Yes, quadratic must be in standard 4. Sometimes you may even get a mark because you would be awarded for knowing and noting that technically, essentially, zonke bonke the-quadratic formulas are applicable. Wafumana, one tall. Anyway, guys, that would be a very nice 100 marks there with some learning points. I hope it was worth a while. I hope you guys have learned something. If you're interested in all of this, I'm going to put it down in the description. But I think this graph of ours, though, has been messed with too much. So maybe if I try to clean up the mess, but I want the tangent to be there. Yeah, I want the tangent to be there, but the axis of symmetry, I don't think it's needed. The axis of symmetry and bengafuni ngawe ke wena man. Bengafuni ngawe man wena man. Qela kakubi san, qela kakubi. I did not argue. Yabona ke. O tlo nseleka jwalo. Na ke batla o kgena jwalo, wa bona. O batla ho nsenya. I think everything is perfect, so I'm going to publish this as it is, guys, with all these extra notes, and hopefully you're gonna use these to good effect and get yourself somewhere in a good position. So I will put a copy of this question paper. This was from the Northern Cape 2025. This was an excellent question paper. I have not seen such a beautiful Term 1 question paper in my life. This is how grade 12 should be introduced to matric. They need to know akukho kwatatomncinci okanye kwamalume. Asiniqhelisi tu siyanivuthuza. These ones were given a proper introduction to matric so that they know we are not here to play, guys. We are here to work hard, okay? And smart at some point. Because hard work sometimes is detrimental when it is just unduly hard. There are some moments in life where you just have to simplify things and make it easy for yourself, or else you're not going to keep up. Remember, as we grow, guys, we do not have much strength. We lose it. There's too many things that preoccupy our mind. So essentially, we need to use our experience to move around. So guys, this was a beautiful question paper. I like it. You see, I even got creative today because of this. Anyway, guys, that's it. You will find a copy of this question paper in the description down below, together with this memorandum of ours as it is down below, and use the video as an aid to learn. If you're a teacher, I hope, guys, I was able to add a cent or two into your techniques on how to create questions, and you can see when imperfections kick in, how to polish those, and also how to create these questions in the first place. And for students, I have shown you guys how to understand a question, then bring back the bank of knowledge that you already have, knowing how to look for clues as to what is needed, And then, of course, performing the operations as you know how. I don't know how many times I've told you the three-step approach. It is the essence of mathematical problem solving. Otherwise, guys, leave a thumbs up. Please don't rob me, hey? You've been robbing me, guys, with thumbs ups, eh? You've been robbing me. I cannot. It's a matter of urgency, this situation, guys. I cannot have a video that goes to 100. Okay, that goes to 1,000 views with just 5 likes. Or even likes that are less than 500. Come on, guys. You want to tell me that all these 1,000 people who looked, they didn't want to leave a thumbs up? Come on. Sanba no more, guys. Sanba no more. Tlohelang ho ba kgopo. A ke le mphento e cheap, man. Wena fela ha o shebile video ya ka, wena wa click a like. A o etsetse nna ha ke na taba le hore le a isheba kampa ha le ishebi. Ntho e ke na leng taba le yona ke hore ke batla ho fa ba bang monyetla wa hore ba tsebe mathematics ka tsela e nepahetseng. Wa e bona ntho e. Jwale he o etsetsa ba bang e seng nna. Ha ke na taba le hore wa isheba kampa ha o ishebi. Fela ha o ishebile he, nketsetse favor tu. Yetsa monwana phezulu, man. Bana ba bang ba tlo kgona ho bona ntho ena le bona. Ba fumana monyetla wa hore ba be le tlhalohanyo. Ka Sepedi, le tlhalohanyo. Ba kgone ho tseba hantle. Hantle fela. They must have the best of understanding. Give them a chance, guys. Give them a chance. My students are at universities, guys, and some are almost done. I mean, I think the first student of mine and the very person who forced me to do online lessons was a brilliant short man from the Northwest. He's short from the pictures, but I don't know. He's probably tall. I never met him in person. You know that guy, when he found my videos on the channel, he requested for online lessons. I never thought I was going to do the online lesson. I was comfortable just, posting things on YouTube. But that student said, I want to understand physics. And I also want to understand mathematics. And I think I need a bit of a, a closer look into these things rather than just watching the videos. I want to ask questions. Well, I ended up buying the Samsung S8 Ultra. No, S22 Ultra, the phone. Because I looked and looked, I was like, that thing has an S Pen. I'm buying that one. So my S22 Ultra gave my student a distinction in maths and physics. Okay, because we did a lot of work there. And now he's doing 4th year medicine at the University of Pretoria. So, hey guys, I'm gonna leave a legacy behind of true intellectuals, not fake pops. Is it fail pop or fake pop? I'm not gonna leave people who look like they know. I'm gonna leave behind people who actually know. Because after he made it, he's been sailing, guys, and he's not failed at all. Instead, he's excelling. So I do believe he's gonna finish on record time. And then my other students, are far, guys. I've got nurses there coming up. I've got clinical associates coming up. I've got chartered accountants in PE. The boys from Tembisa and Limpopo. They are there, the beasts. They're in NMMU, and I'm about to join them. By the way, guys, I'm going to be moving back to PE soon. So I'm leaving this godforsaken town of Umtata. This place is bad. Hi. And then I'm gonna be with my boys. We're gonna chisa the nyama on weekends and get my boys nice and healthy so that they can nail these degrees. I want to see them graduate, guys. That would be the proudest moment for me, because I remember one of them when he was upgrading his matric in 2023. You know, when we worked on these things, I remember when they finished writing, especially maths paper 2, he was like, I remembered saying this. And I was like, I can see this future. I can see this dream. And he is realizing that dream right now. He's becoming a chartered accountant. So guys, I tell you, it could be you if you take these necessary steps to not sit and be laid back and wait until the last minutes and start making noise. Remember, I could die any day. God forbid, I could die any day. And what if you only need me to make it? So take advantage. This channel can be taken down by any means necessary. You never know. There are things that happen in these platforms. Find that they report you for some things and then they take down your channel. It's over. Now you lose all of these things. So take advantage of these while they last, because they may not last forever. Anyway, guys, I'm gonna preach. You know me. I never stop talking. I even talk in my sleep, so I never really stop talking. So yeah, wasikwa waphola lo mlomo uyathetha qha, ayikho enye into yenzayo. Anyway, guys, goodbye. I will see you in the next video. As I said, leave a thumbs up. Please, you can subscribe and hit that notification bell so that every time I post some random videos that you may not expect, you don't miss them, because they are directed to you actually, especially you who's going to miss them. So don't just subscribe and not hit that notification bell. Be able to see all the posts as fresh as they come. There will come a time when I will restrict the viewing. Leave those to members when I decide, because there will be a time in the near future where I will monetize my channel and I will require people to pay even for my lessons. Because yeah, guys, at some point there has to be rewards for what I'm doing, but so far I'm still doing community service. There will come a time when I'm going to be doing a corporate business. Hey, yeah, anyway, guys, bye bye. Next time. Ciao.